Welcome everyone, this is Michael Gibbs. How are you all today? Can you hear me? If you can let me know in the comments section so I know you can hear me. Hello Eric, hello Thajo, hello Guy Wittenhouse, Arun. I see you're there in the chat. Welcome, can you all hear me? Someone can just let me know. Amaranth, thank you for letting me know. Welcome. Derek, so happy to see you here. So today it's going to be Dave. Welcome Priscilla, welcome 4D Robotics, welcome Jay. So happy to have you all here. Today we're going to have a slightly different agenda for the day, but I think everybody's going to have a really good time. Welcome Caesar. Today what we're going to do is in the beginning of this session, what we're going to do is actually we're going to cover some of the AWS Advanced Networking again, and this is the fourth day of the AWS Advanced Networking Bootcamp. For those of you that were not here from the beginning of the class, I'm Michael Gibbs. I've been working in technology now for well over 25 years now, 1993 to be exact, but we don't like to talk about that because it makes me feel on the older side. But anyway, I've been an architect for almost all of this time, and for well over 2 decades, I've been mentoring people, helping them find their first tech job, their next tech job, or build a great tech career. So that's a little bit about us. I'm the founder and CEO of Go Cloud Architects, and we're an organization dedicated towards building very high performance cloud computing careers. So today when we cover the last components of the AWS Advanced Networking course, we're going to do that in the first half. And then the second half, what we're going to do is we're going to whiteboard it, and we're going to architect, and we're going to design solutions. We're going to show you how you create internet access, for example, for web servers. Maybe we'll do some routing labs. So we'll do these in architecture environments. So I want everybody to have a really great experience. So if you're ready to get it started, in the comment section, put Cloud Architect, and I'll know you're ready to get started. It's been a long week, so I want to know everybody's here, excited, awake, alert, and oriented, and motivated to get started. So we're going to begin today's section, and what we're really going to be talking about is more on the monitoring and the troubleshooting side. So we want to make sure everybody understands that. So for those of you that are somewhat new to AWS, and I don't assume that's for most because this is more AWS Advanced Training, but I want to make sure everybody knows, we're going to be talking about monitoring. And the primary monitoring tool you're going to be using with AWS is going to be CloudWatch. So when we start talking about how to diagnose and troubleshoot, I want you to at least understand where we're coming from. So CloudWatch is basically your basic network monitoring or your monitoring systems inside of AWS. And you're going to be able to set this up to monitor your VPNs or your direct connections. You'll be able to see how much traffic is actually being sent on your network. CloudWatch will let you know if your VPNs and connections are, say, up versus being down. You can even set up a CloudWatch alert to basically tell you, this link went down. So you're going to have to monitor systems. CloudWatch can also help you collect VPC Flow Logs. If you remember on the first day we talked about Cisco NetFlow and how Cisco NetFlow were things that people like me working in the network architecture world were able to start looking and say, okay, traffic from point A to point B flows over the network like so. And now we know information about it. So I talked about Cisco NetFlow, and then I said that AWS has a flow log, which is very similar to NetFlow, which gives you information on your traffic. It's kind of almost like a limited protocol analyzer or packet sniffer where you can see your source and destination address. And I showed everybody an example of this before. And obviously, anytime you're using a sniffer or protocol analyzer, you can see your source and destination traffic, whether it's accepted or rejected, the types of protocols and port numbers. You're in a good position. So in my world, because I come from the network world, and I've spent decades in the network world, the network is the center of everything. If the network's not there, your website doesn't work. If the network's not there, your database doesn't work. If the network's not there, any function you have will not work. The network is the foundation, so it really matters. So what happens when things break? And trust me, they will break. So the real key is, no matter what, being able to figure out what happens. For example, let's say you have a direct connection between AWS and between you and the cloud. Now, it's not exactly a wire. Even though logically it's a wire, it's not a wire. So what could go wrong? In your data center, you could have a problem with your router. You could have a problem with the service provider's connection to the Direct Connect Location Center. Now when you get to the Direct Connect Location Center, you could have a problem with your router there. And the cross connect between your router and the switch of the AWS switch, they could have a problem with the cable, they could have a problem with that switch. And then AWS could even have a problem with their backbone. So these are the kind of things that could go wrong, and you're going to have to figure out where the problem is so you know how to get things fixed. Now the good news is we have some pretty basic network tools that work really well. So the first part of troubleshooting is to figure out what's going on. So we're going to talk about this from the server perspective. So step one, if someone calls you and says, I can't reach this website, and the website hosted in your VPC, go from outside your VPC. Here's what you need to do. See if the server is reachable. How do you see if the server is reachable? Ping the server. Ping www.cisco.com. If you get an ICMP echo reply that says, yes, I've seen it, guess what? It's there. Good. Now, if you get this reply, you know the connectivity is good. But what if you don't get a reply? Now you've got to figure out what's going on. So if you ping something by its DNS address and you don't get a reply, a couple of things could be going on. Either the thing could not be there, or you could have a problem with DNS. For example, if you have a problem with DNS, you might not be getting the resolution of www.amazon.com to the actual IP address that it actually is. So first start with the DNS name. Now, if that doesn't work, try the actual IP address, because maybe you have a problem with the DNS. And if you can ping it via IP address, but you can't ping it with the DNS name, guess what? You've got a DNS problem. If you can't ping it with the name, and you can't ping it with the IP address, you've got a network problem. So you gotta figure out what's going on. What's going on? Is the data being lost? Is the data being blocked? So ping a server, and if you don't get a response, figure out why. So a couple things could be going on. You could have a server that's behind a firewall that's not allowed to respond to a ping, and if that's the case, you need to understand that. But even if that's the case, there's still things that you can do to figure it out. So phase one is ping it. Now, if you can't ping something, you got to figure out where your messages got lost. So this is where you're going to do a trace route. And the trace route is going to give you some pretty good information. So for example, in this environment, I'll actually show you what a trace route would look like coming from my PC to Cisco. Just bear with me a second. So you go to ping something. Let's say I went to go ping Amazon.com. Let's say, for example, next. If I can't ping it, I gotta figure out where it is. So I go to my computer and I type traceroute and then the address. Now, if you're in a Windows system, it's trace RT, but it's really the same kind of thing. And what's going on is you're sending these ICMP messages and you're trying to figure out where things are or where things got lost. So in the process of doing first the ping, it either gets there or it doesn't. And then if it doesn't, figure out where your message is getting lost with a trace route. So ping it first. If you can't, figure out where it gets lost with a trace route. Now look at this trace route over here. I'm going to Amazon.com. Now you can see the first hop, second hop, third hop, all the way to the 8th hop. Now when we get to hop 9, we get to star, star, star. Now in this case, the website was up because we were able to ping it. But and in this particular case, section 9 is the firewall, but let's just pretend it wasn't. So if I went to ping Amazon and could not, and then I did a trace route to Amazon, and I would see where the message got lost, which in this case is 8.12.126.233.130. That's a router. So if I tried to ping the website and it didn't exist, and I did a trace route and it got stuck, it's step 8. 12.126.233.130, what do you guys think I would do? I would SSH into the router 12.126.233.130 and start looking in the routing tables to try and figure out what's going on. and see if it's missing a route, see if there's a routing loop, see if there's an uplink or a downlink. That's what I would do. So step 1, ping. Step 2, go look at the thing where the messages are being lost. Now when you're in that router that you SSH into, look carefully. Is there a route in the routing table? If the answer is no, now you know why you can't reach it. Go figure out what's going on with the routing. Is there something going on with the BGP policy, the OSPF policy, what have you? You got to go figure that. Now, you may have a route to the destination. Now remember in BGP we talked about you send them routes and they send you routes? I can have a route to the destination, but if the destination doesn't know how to reach me, it's a problem. So let's say, for example, I wanted to go visit Alonzo in Texas. If I have a route to him and I can't get back home, it's kind of problematic for me. But see, with the internet and with network communication, it's bilateral communications. So if I send a message to Alonzo, but Alonzo can't send the message back to me, we can't establish a TCP session. I can't send an ICMP echo or a ping and get a reply if the reply doesn't know how to go back to me. So not only do you need a route to the destination needs a route back to you. So when you go to this router where it's lost, check and see if you've got a route to the destination and also verify that you've got a route back to you. Now, are there any links that are up and down? Any WAN connections, any serial links, and a gigabit Ethernet links, 10 gig, 100 gig links on the router, are they down? Are there any routing loops? Meaning, for example, was there some kind of weird route redistribution or something where you're taking routing information from, say, BGP, putting it into OSPF, popping it back into BGP, all kinds of weird things like that. You'd be surprised at the things that you actually have to do when you buy and sell companies in networking. So these are the kind of things. Is there an ACL in the way? Now, when you're dealing with these kind of things, this is where you're getting into some seriously heavy-duty kind of work. With access control lists to things being blocked. So once you start getting beyond this, this is realistically speaking where network engineers are going to, like me, are going to get involved. So first, reach the destination. Is it reachable? If the answer is yes, you got no problems. Figure something else out. It's an application problem. If it's not reachable, do a trace route. Figure out where your data stops. And where your data stops, go to that router and then hop router to router to router to the destination and check your routes. Do you have a route to the destination? Do you have a route back to the destination? And because this is kind of academic and ethereal in nature, if you guys want to do some joint troubleshooting today, we can do something just like that. I'm happy to do some with you, with our architecture work. So, but beyond this kind of stuff, this is realistically speaking where you've got some issues. Now, regarding DNS, initially, speaking previously, I told you could potentially have what's called the DNS problem, meaning that let's say you can't ping a server by its IP, by its name, but you can via its IP address. So how are you going to find out the DNS name? Well, the way you can figure out a DNS name is you can do an NS lookup. So if you do an NS lookup on Amazon.com, what you find is the following. You can see my DNS servers, which are 8.8.8.8, which are Google's anycasted addresses. You can see, for example, the actual IP address that I'm actually connecting to, which is the IP address of the CloudFront distribution over here. So I should be able to reach 13.32.66.10. If I can't, there's a problem. So those are the kind of things that you realistically know. Let's talk about some other network troubleshooting tools. Some other network troubleshooting tools are packet sniffers and protocol analyzers. If anybody's not used to packet sniffers, basically what happens is we would take a switch, for example, where the information exists, and on the switch we can only see broadcast packets inside of a VLAN. So what we actually have to do on the switch is basically produce something called a span port, and we have to create on the switch to be able to figure out what's going on. You can create a port that will mirror all the traffic from a VLAN and send it out this port, and this is where you stick your protocol analyzer. And a protocol analyzer will let you evaluate the traffic that's moving through your network. And every one of you should know how to use a protocol analyzer. It's a tool you're going to use a lot in your career. If you've never had one, don't worry. You can get one for free, like Cisco Wireshark. It is fantastic. If you're on a Unix Linux machine, you can do a super user or a sudo and then TCP dump minus the interface number. And I'll show you guys how to do that later today. So what's going on is when you can't reach your data, you got to figure out what's happening. And you can do this with a packet sniffer or a protocol analyzer. Early in my career, I think, somebody called me Sniffer Boy. And realistically speaking, I was young and I literally was plugging in a sniffer all over the network to see all kinds of things that I found. And you know what? I found lots of cool stuff. I saw everything that you couldn't possibly imagine that was on the network, and then I go from Sniffer Boy to Mr. Policeman. Excuse me, sir, you need to unplug that server. Excuse me, ma'am, you need to unplug this. Excuse me, you need to do this. And then I locked down the ports on the switches and they never got plugged back in again. But that's what you had to do. So understand these things. So what are the phases? Somebody calls you and says the server's not there. Well, first, see if it's there. If you can ping a server, but it's not serving things, well, you've got a problem. What's the problem? Maybe it's a problem. It's a problem with the server. If you can ping it via its IP address, but you can't ping it via its DNS name, you've got a DNS problem. If you can do it, if you can't ping it, you do a trace route. You see where your trace route gets lost. You go to that router. You check the routing tables to and from what's going on. You check the status of the links, and you go up and down each router along the path until you find your problem and your problem's solved. So these are typically the way we do things in network troubleshooting. But we're with AWS, so you're still going to do all those things. But we also want to teach you a little more about CloudWatch and Cloudtrail, just to make sure you guys kind of understand the concepts. So as I mentioned, CloudWatch is going to be a monitoring service, which normally monitors your applications, but you can monitor your network as well. And because this is some AWS training, in addition to our traditional architecture training, we want to put a little more certification components here. So while we're talking about networking, still remember that CloudWatch has these built-in metrics. The basic CloudWatch will give you CPU, disk read and write, IOPS, and basically network utilization. So basic CloudWatch gives you minimal stuff, but it's still there. Now, if you need to monitor your system better, and who doesn't need better monitoring other systems? Everybody does. That's realistically speaking when you're dealing with custom metrics. And here you get memory, your memory, API, all kinds of things that are necessary to really run your systems. And of course, CloudWatch has an alerting type systems such as CloudWatch events. Now, typically speaking, people think of CloudWatch events basically just sending you an SNS message that basically says, hey, there's a problem. But CloudWatch events can do a lot more. CloudWatch events can basically enable you to do something. So you could take a CloudWatch event and use it to trigger autoscaling. You can set up a Lambda function, an email notification, actions on a container, and many other things. So CloudWatch is a monitoring service, but you can integrate it into some remediation services as well. So CloudWatch is one of those cool kind of things. And I mentioned, the CloudWatch events profile. Here's the way you're going to do it. It's basically a service to deliver a really near real-time streaming of events. So you're going to set up a rule that matches a certain event, and then you're going to route that thing to a function or a stream. So ultimately what happened is, let's say I set up something I'm not supposed to do. CloudWatch events will be aware of it, and it can either set up a Lambda function to remediate it, it can text message via SNS a manager from that security team or do something like that. So if CloudWatch is monitoring, because it may pop up on this exam, what is Cloudtrail? Cloudtrail is auditing. And we're not going to be talking about this stuff for too long. We're going to get on to much more fun stuff really, really soon. So Cloudtrail is auditing. So in certain industries, it's really, really, really important to know certain things. So auditing. So if you've got a compliance thing, Cloudtrail is where you're going to be. If you want to be able to track changes that were made by certain users, Cloudtrail is going to do it. So Cloudtrail is a really great way to figure out what happened. So you get an outage, you look at the Cloudtrail logs, this person configured this. Okay, it broke it. Let's go fix it. It's great. So especially if you're in the finance world, or if you're in the healthcare world, or if you're in any one of these worlds, for example, what's ultimately going on is you need to have some form of logging function. So at least understand that. And the logging function is going to give you a lot of information. So when you set up your Cloudtrail, it's going to give you basically what am I looking for? It's going to give you an event history. And in the event history, you'll be able to see the kind of things that happen. And when you set up the trails, you're going to be able to set up basically a local trail and more of a global trail. So just look at it this way. A local trail is local to one region. And this is going to store your CloudWatch logs into a single bucket. And this is the default option. And it gives you comprehensive logging and auditing functions, gives you a record of everything. So, going back to the troubleshooting side, we talked a little bit about auditing, we talked a little bit about logging, and we talked about some ping, telnet, traceroute, those kind of typical network troubleshooting skills. So, when something breaks, what do? Troubleshoot it. What is the first thing you want to do? Maybe look at your logs. Typically speaking, you've got these sys logs, these big logs of all kinds of things going on. Your logs can tell you a lot. Your logs may tell you somebody made a change. Your logs will show you a downlink. Your logs can help you identify a DDoS attack. Logs, logs, logs. And if you're looking at logs, it's probably because you're in the sysops or the maintenance world, not the architecture world. Now, this is where those scripting things that those sysops people need to be really good at. Parsing through logs, looking through a giant log file, grepping for a certain thing. So being able to, for those people that don't know what I mean, the grep is a common Unix command. Basically, you can dump your log to a file and you can search for certain things and then you can output it to another file and then build yourself a really good list of all the things that go wrong. This is a great job for the sysops people. They tend to be really great at these things because that's what they train in. In architecture worlds, you're going to be more of a designer, so you're going to be doing less of this operations, maintenance, and troubleshooting. But occasionally, because you're the person that designed it, you may still need to be able to look and see some of the things that are going on. So that's kind of your logs. So what are the things that typically go wrong with networking? Well, these are the following that, in 25 years of network troubleshooting that I can tell you are the most common. First and foremost is these routers are, most of the time, somebody just configured something wrong. Half of the troubleshooting I've done, somebody did something, they didn't understand the commands, they put it in, things just didn't work. So that's the most common one. The next most common one is the link is down. So for example, if you're purchasing a direct connection between New York and London or a private line or whatever, if it goes down, your routing breaks. If I'm trying to drive over to Ian's or take a boat over to Ian's house, and if the boat breaks, I'm not going to get there. Well, that's kind of like the line being down. The path gets broken, you're done. So link goes down. Second most common. Now, these routers themselves are computers. And what do we know about computers? They occasionally crash. So occasionally, very rarely, but occasionally a router will crash, and that will give you something. So when you call tech support for a lot of these companies, you say, hey, it's Mike. Got a problem with this router. You know what the networking vendors will do? They'll come up with a bug, and they'll say, upgrade the operating system and reboot. Now, is it the bug or is it the reboot that fixes things? Most likely it's the reboot. So kind of keep that in mind as well. Sometimes you find stuff and just a reboot is going to fix these things. But, when you're dealing with 5 nines network, 99.999% of the time systems need to be up. And a reboot can take you a few minutes by the time the systems go down and up and reestablish all their neighbor adjacencies with your routing protocols and such. Do you even have that? So be careful about your reboots. Next most common problem you have is the route's not there. The route got missing. So router somewhere in the path gets broken, the link gets broken, the process in the router crashes just like a computer. You don't have a route. And if you're dealing with VPNs, there's a problem with your IPsec tunnel, which typically means an internet connection is down somewhere. But of course, if you got an issue with your encryption keys, that can break things too. Now, they're the common network problems. Now, what are the common things that would occur in AWS outside of the network, which some people would call the network, I would not? Well, you could have an access list in there, which is too restrictive. Super common. When people start putting in access lists, stuff breaks, just breaks. If you've got a security group protecting traffic coming into your servers, guess what? That could be too restrictive and that can break things too. So now you're combining a network ACL, a security group, a firewall, and a whole bunch of policies. That could be broken. So let's say you installed a host-based firewall on your server. And your server needs to be open on port 443, but your host-based firewall is blocking it. Again, that can do it. So that's something else that can happen. You also may have a network-based IDS IPS system. And your network-based IDS IPS system could basically think your application is behaving like a worm virus or a security exploit, even though it's not. That could break things too. And I've seen it multiple times. You could also have an incorrect IAM policy. So these are the kind of things that go wrong. So I want to repeat them again for you. These are the things to look for. Router's been misconfigured somewhere along the path. A link bin goes down. A process on a router has crashed, like OSPF or BGP. You don't have a route to the destination. You've got a link that went down, or you've got a problem with your IPsec tunnel, which is either a key problem or an internet connectivity problem. Now, inside of AWS, you've got a network ACL problem, a security group problem, or if you're using external security appliances for some reason, guess what? They might think your natural traffic is not good. Or you've got some software that's blocking something, or you've got an incorrect IAM policy. This is 90% of the stuff that you're going to deal with over the course of network troubleshooting and troubleshooting on the cloud. I mean, you could typically things that your traffic is just getting black holed somewhere. So before we get, where we're going to head to next is we're going to be talking about hybrid cloud architectures. Just to let you guys know for the day, what we're going to do, we're going to talk about hybrid cloud architectures, and then we're going to talk about ways to make that work, and then we're going to talk about some billing concepts, and we're going to talk about some high availability network design, and then we're going to have some fun doing some architectures for different situations. We're going to whiteboard them out like we did yesterday. I had sent some people home, and then we started doing this, and we started getting so many more people there that we're going to spend at least an hour, maybe an hour and a half today doing some architecture fun. So if you're up for architecture fun, say architecture fun in the comment section. If you're enjoying what we're doing, please leave a like and share this information with others and bring others on the call. I will stop now to answer 10 minutes of questions prior to moving on. So let me go look and see who has questions so we can answer them and then move on. Knowledge Drive, can you use Wireshark in AWS on a very, very, very limited basis? You can use it on the connections to AWS. See, the problem is in order to really use a good sniffer like Wireshark, you need what's called a span port. And you can't really create a span port on the AWS switch. They won't let you. So what you can do with Wireshark is going to be very limited. Now you could go to the server that's having a problem and run Wireshark on that and get some information. Or you could do a TCP dump, which would also give you some information. That's like a built-in sniffer to Linux. But you're going to be limited in what you can do there. But you can definitely use the Wireshark on the way into the cloud. Also note, my associate Chris has shared a link to the architecture challenge which we're running on Tuesday. I highly recommend everyone do this. This is going to be like a real day life of the architecture world. I'll provide a scenario. The students will ask me all kinds of questions, and from there you'll design a solution with my help. It is a world of fun. It is every Tuesday. Chris posted the link to that. I highly recommend it. Also, if you're not one of our students and you're interested in what we do, we have a cloud architect training program that's designed to take people from basically wherever they're at and helping them get their first cloud architect job. I'll pop a link in that in the description below as well with a 25% coupon. And for people that are interested in training with us, I'll leave our phone number and people can ask questions. So let's go make sure we've got some questions on troubleshooting. I'm trying to see if anybody else has any more questions in here. Is Cloudtrail and config overlapping? James Ma. In some ways there is. So config will basically let you know if and when something's been happening that's not according to policy. And that's great. Cloudtrail just basically logs everything in an auditing fashion. So config is more, you set a policy, and if something doesn't configure or adhere to your policy, config notifies you, where Cloudtrail is basically makes note of everything that's happened, every kind of configuration change, and gives you better auditing. So they're slightly different, but they do similar things. Hand of God, thank you so much. I'm so grateful for your kind feedback there. Raphael, yes, effectively, anytime you have a route that's going nowhere, whether it be a route to null zero, or whether it just be a route that's going to a destination that doesn't have the next hop, you'll definitely lose some traffic. Completely agree. BV, please share a course structure or content. BV, which course are you actually referring to? BV, if you're asking about our training program, you can find it on this page. It'll explain everything that you need to know. Basically, the way we do our training is as follows. Twice per week, we have live architecture training, 3 hours twice per week. And on these live Zoom meetings, we design architectures together, just like a real-life, everyday job at the office. The students will ask questions to the executive, which will be me. I will answer these questions, and after I answer the questions, based upon the questions, the students will design an architecture. Then, in between these live sessions on Monday and Friday, we have homework assignments that the students do, for which they submit for feedback to our Slack channel, and we get feedback. Homework assignments could be on any one of the following things. They could be based upon architectural work and case studies, presentation skills, communication skills, interview training, career planning, salary negotiation, projects involved, all of these things. Because as a cloud architect, you're a hybrid between a business executive and a engineer, and we have to train you for both, so we do that. So lots of interview training, a lot of everything. We do have some AWS training in there, but that's the most minor part. We have approximately 30 to 40 hours of AWS training, but the remainder of our training is cloud architect training, which is much more important. Certification is not enough to get hired, but certification with architect training and communication skills training and presentations training and interviews training helps our students get hired all the time. So it's a very different architectural program. Our program is about 250 hours in length, and we cover every skill that's necessary to go from either new to the cloud and hired or certified and hired. So it's something we've been doing forever. Been helping people get their first tech jobs for well over 20 years, and I've always used a model like this, and our students are highly successful. BV, I hope I answered your question, and if you've got more questions, you can call our office at the number that I just pasted in there, and I'm happy to answer questions, or someone from my team would be. But I don't want to spend the entire session talking about our training, but I'd love to speak with you if you're curious. Now, that's a great question. How much time does an architect spend on troubleshooting? Hopefully none, BV. But that doesn't mean you won't. It all depends on the level of architect you are. So early in your architecture career, you're going to be primarily the most technical. And when you're the most technical, you're going to be just like one step above the engineers. You might have that solution architect world. And in that solution architect world, you're still a systems designer, but you might still be technical enough that when things actually break, you're going to assist the cloud engineers to troubleshoot it. Not often, but it does happen. Now, as you move up the ranks from solutions architect to cloud architect, you're going to be doing a lot more design, a lot more presentation, a lot more communication, a lot more of all the other intangible skills. Now then, you're probably going to be doing troubleshooting a lot less, like a whole lot less. Like you might not do any of it. And then once you start moving into these enterprise architect roles, which my students will be able to do because we spend so much time working on the soft skills, emotional intelligence, business acumen, communication skills. And when you do that, your salary escalates like a rocket ship. And I've spent many years in those roles. From there, that's when it becomes more communication skills, and you're almost never going to be doing any troubleshooting. So architecture is really a design position. It is not hands-on. For architects means designing the systems, putting the pieces and the parts together. How do they work together? That's hands-on for architects. Hands-on for engineers is building it. Hands-on for sysops people is maintenance of things and things like Terraform and automation. Hands-on things for DevOps people are software releases, and these are very different careers. So, in architecture, the troubleshooting is going to be minimal, but you still need to understand the basic methodology. BB, I hope I answered your question there. I have time for one more question before we go to the next section, so if anybody's got some questions, please answer them. I don't want anybody to walk away from this week without getting a great education, and part of that means getting your questions answered. So please let me know how I can help you along the way. I know there's a delay of about 45 seconds, so I'm going to wait about 45 seconds to see if there's any more questions prior to moving. Otherwise, if you're ready to go, type Cloud Architect in the window, since we love Cloud Architects around here. ME, you're currently Cloud Practitioner certified and you're going after your solutions architect. Can you get employment with only your associates, or do you have to get your professionals to get employed? Well, ME, I don't know your background. And if you want to tell me your background on the next break, I will happily answer that for you. Because if you've got a big background in tech, you don't need any certifications to get hired. If you are coming from a sales background, for example, the Certified Solution Architect professional might be enough to get hired as a cloud architect. If all you have is a Certified Solutions Architect professional and no knowledge of the network and the data center, and you've not trained the communication skills, the business acumen, the writing skills, it'll be near impossible even with the Certified Solution Architect professional to get hired. So, Emmy, we can do the following. And that's an answer that we address every single day of the week. You are more than welcome to call us, Emmy, and we can gauge your situation, put you through a mini interview, and recommend a plan for you. I've dropped a link over there in the description below. Or in the next break, you can provide some more information to the chat box, and I will answer your question in much more depth. But the information we're going to need is what is your current background, what is your current experience, and exactly what is your goal career. From there, we can advise you on what minimum levels of certification are and the things you need to know. So let's go back to the content, and Emmy, I am more than happy to answer those questions, so provide that information and I will let you know. So now let's talk about some hybrid cloud architectures, and I got to tell you, I love hybrid cloud architectures, and if it's me, most of what I'm designing is a hybrid cloud architecture. I think they're the best, and we'll talk about why. So what is a hybrid cloud architecture? It's actually one of two things. The first hybrid cloud architecture that most people think about is just have your data center and have your cloud. Typical speaking. And this is ideal for a lot of requirements. Look at it this way. If you're going to migrate to the pure cloud, you're still going to go hybrid for a while because basically you've got a lot of stuff in your data center and the cloud. What if you've got an ultra high performance application like a financial trading application? You don't want to put this in the cloud. For $100, I can buy an NVMe drive at Best Buy that's got basically 1 million IOPS. I couldn't get anywhere close to that in the AWS cloud. I can get to 65,000 IOPS, which means if I were to put 15 of the fastest PIOPS volumes together in a RAID 0 environment on the cloud, I might equal my $100 Best Buy drive. But what if I need 10 million IOPS, which is nothing? You take 8 NVMe drives, you put them in a RAID array on your server. You can't do this on the cloud. So if you've got any of these really high performance, low latency applications, you're not putting them on the cloud. So hybrid cloud, great in the migration. Hybrid cloud, super high performance applications, you just can't do it in the cloud. What about disaster recovery? What about keep your data center and use the cloud for disaster recovery? What an elegant solution that is. You can pretty much use disaster recovery. You basically put a backup of your systems, all small instances, and call it a warm standby, if you will. And if anything happens to your data center, your systems can switch straight over to the cloud, scale up, and within 45 minutes to an hour, you're completely up and running. Oh, it's super low cost. So, great for that. What about standalone? For example, what if you just want to keep your data center on the cloud? Or better yet, control. I love the hybrid cloud architecture because no one controls me. I do not like being controlled. I do not like having contracts with service providers. Here's why. You call the cable company and you get a discounted rate for 12 months, and at the end of the 12 months, they jack up your rate. You know what? The phone company does the same thing. And the cloud providers will give you a beautifully discounted rate for the first year, and then your things go up. But is that okay? I don't know. It depends. It's going to be dependent upon your situation. If you move to the cloud and you find out it doesn't work and you're in a hybrid cloud, pull it back in. Nothing to do. But if you're off cloud, it could change things. So these are what considerations you should think about. So we're going to talk more about each and every one of these systems again and how it works. But let's look at what you would typically look like in these hybrid cloud environments. Hybrid cloud is simply as follows. You're going to basically keep your data center connected to the cloud, usually with a direct connection and a backup with either a backup direct connection or a VPN. And that's it. That's your hybrid cloud. It is a beautiful, elegant solution. Now let's talk about data center offload. Look at it this way. Organization maintains the data center. An organization can set up the data center for the use they need most of the time. So traditionally speaking, the way we do our system design is in a data center, we build for peak, meaning we build for the busiest your server is going to be at that 1 minute of the year where it needs to be, because organizations can't afford to lose business because the server is busy. But what happens in most organizations? For example, let's say, your servers run at 15% all year long. And maybe around Christmas time, they run at 80, 90, 100%. So organizations are paying 9 times more than they need to all year long for that Christmas season, say for a retail environment. What if you could size your data center properly and then offload extra to the cloud? Well, now you got the benefits of autoscaling, which is one of the primary reasons people love the cloud, because that's the benefit of the cloud, autoscaling and agility. You can add new services as needed anywhere on the cloud, but you still have your data center. So if the cloud provider says, I don't like your business and they want to kick you out, you say, bye cloud provider, I still have my data center. Oh, by the way, let me go to the next cloud provider that doesn't care. You've got that option. Cloud provider raises your rates. Bye cloud provider, I still have my data center. So when you're doing this hybrid environment, it is cool. But you want to get really good in your hybrid cloud? You want to really have the best situation? Run a cloud in your data center and offload to the cloud. So instead of having your standard servers, just basic servers, and then your cloud, get better. Organizations can use an OpenStack Ansible cloud, a new Nutanix cloud, and this stuff is really great. Basically speaking, you set up a cloud in your own data center. You install all the cloud software just like all my students do when they build the cloud, and all my students in their cloud architecture development program build the cloud. In fact, they're building the IBM OpenStack Ansible cloud, like all these organizations are using. So you have a cloud in your data center, which means simple provisioning in your data center, auto-scaling in your data center. And when you build these clouds, you can even provision the AWS cloud or the GCP cloud or the Azure cloud directly from your own private cloud. So now you can have hybrid clouds, multi-clouds. You are not the mercy of anyone. Anybody wants to raise your rates, who cares? So you get the cloud benefits locally and the cloud benefits on the cloud provider, and it's simple and it's dynamic and it's easy. This is as great as it gets. So you basically set up your data centers. You'll set up a DNS policy, for example, that will offload your web stuff. Your web servers get too busy, latency goes up, migrate to the cloud. Everything works perfectly, wonderfully, and you have full control. So hybrid cloud architectures are simple, elegant, beautiful, and I highly recommend them. Now, let's talk about disaster recovery, another beautiful, beautiful place in the cloud and hybrid architectures. You got your data center up and running. Use the cloud for DR. Just DR. And this is, again, a perfect, brilliant way because you've got your data center. What do you get in your data center that you don't get in the cloud? Much better performance and 100% control. What does the cloud give you? Lower performance, albeit, but flexibility, agility, and potentially lower cost, and simplified networking. And the potential to use feature cloud native services if and when people are comfortable with it. Which again are simple, elegant, and beautiful. But it's a matter of understanding what your goals are. So we're going to talk about 4 cloud disaster recovery options to use, and they're all great, and they all have different times to recover your situation, but they also have different cost structures. So we're going to talk about the 4. Now there's all kinds of terms: hot, warm, pilot this. I like plain language. I like things that I understand. I like things that make sense to people. And guess what? When you communicate to an executive, at the customer, they're not want to hear pilot, light, warm, standby, IaaS, PaaS. That is meaningless trash terms that people make up to try and make something so fancy. You can't use them in business anyway, so just erase them from your mind. Pretty much any of the vocabulary that's learned in a cloud practitioner, get rid of it. You're not going to use it in your architecture career. These are terms that cloud providers feel good about, but when you're going to speak to the executives and design a solution, you got to communicate to them on terms they understand and not acronyms. So let's now talk about disaster recovery type architecture 1. This is the simplest and by far the cheapest. To me, this is backup. What do I mean by backup? You take all your data in your data center, you back it up to the cloud. Beautiful, simple, and elegant. Part 1. You take your machines, your virtual machines that are in your data center, and if you're using bare metal systems, You basically would use like a VMware virtual machine converter and then use an Amazon converter to manipulate the VMware VM converter into your system, or you can use an Amazon system to import them. And you're going to import your servers into automated Amazon machine image files, and you're just going to store them there. And you've got databases in your data center. You'll make a snapshot of them and then forward them over, back them up. So ultimately what's going on here, you've got a backup of all your data and a backup of all your servers. You're only paying to store the stuff there, say on S3, because it's just data. Now what happens? If there is a disaster, you go to the data center or you go to your VPC where your things are stored, and you literally start launching your AMIs into virtual machines. You start migrating your data over, and you'll be up and running. Now, here's the downside with this. This is slow. I mean, really, really, really slow. Why is it so slow? The reason it's so slow is as follows. You got to rebuild all these servers, all of them, literally 100% of all of them. And that's going to take some time. So because of that, this is very slow. Now the next option is disaster recovery option 2. Disaster recovery option 2 is pretty much the same as disaster recovery option 1, but you're synchronizing your databases. And the reason you're synchronizing your databases is as follows. You've got your machine image, your data, but now your databases are synchronized. By synchronizing your databases, here's what happens. It speeds up the recovery time because now your database is up. So now the only thing you'd have to do is bring up your other AMIs and data storage like that. So your databases, for example, that's the way they work. Synchronize your data centers, synchronize your database, machine images plus your database, and things are going to work with that. Bear with me 1 second, guys. Sorry everyone, normally we have class on Friday at noon for our students in the Cloud Architect Career Development Program. We announced it, we told everybody on the last call, but sometimes people are still asking the questions. So even though we announced it and posted it in a few places, I want to make sure everybody's not waiting for us. So bear with me. So thank you so much. Option 1, copies of your machine images. Option 2, copies of your machine images with a synchronized database. Now, again, this is going to be a painfully slow recovery. You could be dealing with 8 hours, 10 hours, 12 hours for option 1 and option 2. This is going to be a long time to come back and running. But it's cheap. Why is it cheap? Option 1 is just backup. Option 2 is backup plus synchronizing a database. Relatively inexpensive way to do things. Now let's start talking about backup options, disaster recovery options for organizations that need better performance. Here's where you're going to talk about our other better options for performance. Now these options are getting more expensive. So the first two are really cheap, simple, and elegant. But here we're getting more expensive. So what is the first one? Let's say you've got your data in a center and it's active and it's up and it's running and it's awesome. And then what's actually going on is you've got your primary things going on and your data center is being synchronized to small little EC2 instances that are, say, running on the cloud. So let's say you've got hundreds of servers in your data center. You might have just like a web and an app and a database that you're running, all on small instances, very small instances. So what'll happen? Failure in your primary data center will trigger a failover to your backup data center, and it's going to happen simple. Now, primary data center fails, switches over to the backup data center, and in the backup data center, autoscaling will occur. Autoscaling will occur, and it will take time, and in approximately 45 minutes, the setup will be done. So that's how that works. DR option 1. Option 1 is going on. Basically, copies of your machine images and nothing else, so it's just backup. Disaster recovery option 2, backup plus a synchronized database. Disaster recovery option 3, small versions of every single system that you have running in an auto-scaling group that will scale up. And then afterwards, well, after they scale up, you'll be up and running, but it takes about 45 minutes. So what do you think the last option is? If you want instant disaster recovery effect, what do? Active, active. What do I mean by active, active? Primary systems up, backup systems up at all times. So fast, fast, fast. Basically, systems go down in the cloud, they're instantly up. So let's walk through these one more time. Disaster recovery option 1, machine images in the cloud and your backed up data center. Guess what happens? Data center goes down, you go to the cloud. In the cloud, you have to launch all your machine images, pull all your data. Basically, 8 to 12 hours, you're up and running if you're good. Phase 2, basically the same thing with your database synchronized. Maybe you get up in 8 hours versus 12 hours this way. Option 3, basically if you got your data center and you've got little micro or small instances running in the cloud for your production servers. And if there's a problem, these things scale out, you got a whole bunch more servers, everything runs, in about 45 minutes you're up and running. Disaster recovery option 4, make a mirror image of whatever's in your data center in the cloud and you're going to be in fantastic shape. So something going on with my video, I'm going to blank my screen and open it up. Now we should have good clear video again. I don't know why my Logitech Brio does this, but it sometimes does it. So, now that we talked about the cloud disaster recovery options, and I got stopped 2 or 3 times responding to messages, I want to make sure everybody didn't get lost here. Is everybody comfortable with the 4 disaster recovery options? Just let me know prior to me moving on. You guys get the disaster recovery options? Any questions prior to moving on? Alex, you're good. Thank you for letting me know. Is everybody else good? I don't want anybody being stuck. That's why I'm trying to... Okay, so I see a couple of yeses. Maxim, Alex. Yeah, Derek. Option 3 is my favorite option as well. Seems to be the only one that's really useful. Okay, it looks like everybody's good here. So, if everybody's good here, I'm going to keep motoring through. Because the sooner we get this content done, the more architecture fun we're going to have later. And I think everybody wants to do architecture fun, from what I saw. And I love architecture fun. So, we'll keep motoring through then. So, when you're dealing with these hybrid cloud environments, you start running into what's going on with your data. And... BV, how can you recover if primary is down? Okay, Derek, so before we move on, there's 2 questions. One is from Derek, and that one's a simple question for me to answer. If you're running small instances in the cloud and your data center goes down, what's going to happen? So, great question, Derek. So let's say you've got 50 servers that are web servers in your data center. And they're running on big systems. Let's say 64 cores. And in the cloud, you want to do something cheap. Let's say you want to set up a 4-core system and run it at all times. Now, you're just going to have that 4-core system. It's going to be sitting there doing absolutely nothing. Nothing. It's just going to sit there. Now, Derek, what will happen is the way you'll set up an auto-scaling policy that says, if an outage were to occur, scale out, add instances. And if you've got 50 64-core instances, you may need a few hundred of these auto-scaling instances to scale up. And that's okay, they can do it. But that's the reason we're talking about, creating an auto-scaling policy, and I'm saying it may take 30 to 45 to 60 minutes for all these auto-scaling instances to come up to capacity. Because you're going to be using smaller instances than you would in your data center, because you're trying to basically have it set up that you're paying for nothing or next to nothing at all times, and then when there's an outage, it'll just scale out by adding computer. And this auto-scaling policy takes time, because you're basically going to have your system scale out. and then you may have to run a bootstrap script or something, so it might take a couple minutes per server. So that's where you set like your max thing. It could be hundreds of servers. So that's kind of what we're talking about. Derek, I hope I answered your question there. Okay, thank you for confirming. Now for BV, how can you recover if your primary is down? We just covered 4 options. So let's talk about these 4 options again for you, BV. Option 1, you have your data center up and running, and you've got your cloud, and inside of the cloud, all you have sitting in here are your machine images or storage. This is option 1. So if there's an outage that occurs, you're going to go to the cloud. You're going to launch every server you have from your AMIs. You're going to launch your load balancers and set them up. You're going to copy your data out of S3, and it's going to take a long time, like a whole day to do this, to build out your entire environment, and then you'll be up and running. But it's super cheap because all you're doing is storing stuff on S3 machine images. Option 2 is the same thing, but instead of having your, like say, your web tier and app tier machine images, your database tier is synchronized at all times. So when there's a problem, you're only going to rebuild your web tier, app tier, and not your database tier because it's synchronized. So it's a little faster. Option 3 there, BB, is basically, which is probably the best option for most, is you've got your data center and it's up and running. You got your cloud and it's running small instances. And what's going to go on is you're going to set up a DNS policy, or maybe you're using Route 53. It doesn't matter whose DNS systems you're using. And it's going to be doing health checks to your primary data center. Are you there? Are you there? Are you there? And when the data center doesn't respond, I'm here, I'm here, I'm here, DNS will shift over based on the health check to the cloud, and you should be good to go. Now the last but what's going to go on is because it's small instances, they're going to have to scale out and add systems, and that's going to take you 45 minutes. Now BV, your last option is to run your data center and run an ideal exact copy in the cloud as close as you can get. Full capacity. So if something goes on in your data center, remember you got that health check. Are you there? Are you there? Are you there? If the data center doesn't reply, DNS will reroute it all to the cloud, which is up and running at 100% capacity, which is fast. This will happen in a minute or less, which is great. But here's the problem. This is expensive because you're running a second identical data center. So for a big bank, yeah, but not for most organizations. So start looking at it that way. Did I answer your question there, BV? And Derek, it looks like I got your question. BV, if you can just confirm that to me before I move on. Don't want to leave any man back. Don't want to leave anybody behind. Yes, ME. Summarize for. You've got a data center that's got 5,000 servers in it. In the cloud, you've got 5,000 servers in it. You've got 100 web servers in the data center in option 4. You got 100 web servers in the cloud in option 4. You got 100 app servers in the data center. You got 100 app servers in the cloud. Option 4 is basically making an identical mirror image copy of everything you have in the data center and the cloud. ME. Mr. Sharma, is active passive set up? It's a good practice. Generally speaking, what we typically would do. Totally fine. For option 3. Now, Lama Sharma for option 4. Yeah, it's going to be expensive to run an identical copy and not use it. So it all depends on which system you're using. But active passive is the majority of the way that most organizations are going to design their disaster recovery options. Any more questions before I go to the next section? Yes, Alonzo, option 4 gets real expensive. Most organizations will not do option 4. Kind of organizations that work for option 4 are the big banks, the investment firms, the boutique hedge funds. The kind of companies that when you work for them and it's 6 o'clock at night, you just take a limousine home because they provide one for you. These are the kind of people that have money for these things. I've worked for these banks. They've got lots of money, lots of cool tech. You get to literally play with everything, and your life is really fun. But, you know, the pressure cooker environments, because when things go down, people get stressed. I don't get stressed because, you know, I come from a world where the kind of stress that I'm used to is a little worse than what most people would get in a bank. But, you know, that's the majority of it. Okay, I don't see any more questions, so let's start talking about data in these hybrid cloud architectures. So, You got a data center. You got a cloud. You got this whole data stuff. Whoa, what are you doing here? So in your data center, everything's simple. It's going to be in your storage area network. If you're using block storage, object storage, you've got fiber channel connections coming into your servers. It's all perfect. You start moving stuff over to the cloud. That changes everything, literally everything. So let's talk about it. Servers are designed to use normal storage. What does normal storage mean? Hard drives. Servers are also great with these iSCSI connections or NFS shares because it's file storage. It's what they're used to. Computers themselves are not designed to use object storage. Object storage is just to store stuff. Object storage is different than real storage. It's not regular storage. You're taking data, you're breaking it down into objects, you're putting metadata on these objects. Object storage is kind of a database that's actually got storage, that's got stuff stored in there. Flat, non-hierarchical storage that scales really, really, really well. So that's realistically speaking what's going on there. So when you're on the cloud, unless you're dealing with a system, in which case then you're using block storage, which is a totally different type of storage area network technology to kind of feel like local storage to a host, you got issues. Because what about the stuff you're using in your data center, which is going to be on NFS or server message block shares? And now you're trying, and that's what your computers need to use, even iSCSI. Now you're going to be mapping to the cloud that's going to be using object storage, and you can't use it by a computer for the most part. So how do you make this stuff work? Well, if you're going to be on the cloud and you need to store stuff in S3, which is object storage, and you need your systems to use it, you got to do some adaptation because computers do not use object storage natively. It's not the way they work. So when you're dealing with these hybrid cloud environments and you're working with object storage, you need to do something about it. So AWS helps you with the concept of these storage gateways. And what storage gateways do is they enable you to access things in object storage from your data center, or take your stuff from your data center and migrate that data over to the cloud. So these are what your storage gateways do. And because of that, there's a couple of types of storage gateways, FIAM gateways, and the such. So we'll talk about what they are and how they work. The first type of a storage gateway is called a file gateway. And what the point of this is, let's say you're migrating your data center from your data center in the cloud, or you're creating this nice hybrid cloud environment. You got to get your data to the cloud. So what happens is AWS has this concept of a file gateway. And a file gateway is a virtual machine. And you stick this virtual machine in your data center. And the virtual machine acts as a file server, like a real file server for your systems in your data center. Which means, if you're dealing with Windows, you can connect via the SMB protocol. If you're dealing with Linux or Unix systems, you connect via NFS, Network File System. And then what happens is you mount your stuff to the server, and then the server copies all this stuff to the cloud. So your files get asynchronously copied to the cloud. And there'll be objects now on S3, and all your stuff will be copied to the cloud. Now, additionally, your stuff will be copied with SSE-S3 encryption keys. So your objects that are going to be stored in your object storage are not going to be encrypted. That's how you're going to get your data from the data center to the cloud automatically by mapping your things to this appliance, which is really just a virtual machine that acts as a server that transfers your data to the cloud. So architecturally speaking, what's this going to look like? You're going to have your servers. You're going to map them to the storage gateway over here via, say, NFS because it's Linux, or SMB if you're using Windows. Through your direct connection or your VPN, your information is going to be pushed to AWS S3. Now, you could potentially move it to infrequent access, Glacier, or what you have because of a policy. But really, you're taking your data and you're copying it to S3. That's the way these storage gateways work. Now, there's a couple of other different types of gateways that you can use for your storage environment on the cloud, and they're called FIAM gateways. And realistically speaking, there's two ways you can do this. Way one is with a FIAM gateway. And a FIAM gateway is designed for organizations that are basically going to be data center based. But they still want to keep their stuff stored in the cloud for backup or disaster recovery purposes. And for these organizations, they're going to use a FIAM gateway in what's called stored mode. And I'll show you what it looks like. And when you're dealing with FIAM gateway in stored mode, it's going to take your data just like the file gateway and asynchronously back it up to the cloud. It'll take your data and back it up as an EBS snapshot on S3. Basically speaking, you're going to create the storage gateway, which is a virtual machine, and your systems will mount to the storage gateway via the iSCSI protocol or the IP-based SCSI protocol. Devices will map to this, and basically that'll be the storage. Now, architecturally speaking, you can see what's going on here. You've got your users, the servers in the data center, mount this iSCSI virtual machine, and it copies your information to the cloud. Now, having said that, with the storage gateway in stored mode, you can still pull your information through the from the cloud as well, should need be, should you have something there, and it'll feel like local storage because of the storage gateway. I mean the VM gateway, but still note this is predominantly for stuff that's going to be copied to the cloud from the data center. VM gateway store mode, predominantly for the stuff that's copied in the data center. File gateway, move your stuff from your data center to the cloud. Now after this, we've got one more options with regards to storage gateways. What is that option? It's the VM gateway cached mode. This is designed for organizations who keep their data predominantly in S3. So the previous options were for people that have a data center they're copying to the cloud. Now, what if your data is mostly in S3? No big deal. We use the VM gateway in cache mode. And here's what's going to happen. It's going to make S3 feel like traditional storage to your users in your data center. And that's the purpose of this storage gateway. So what'll happen is you'll set this up, again via iSCSI. Your devices in the data center will map to the storage gateway, and it's going to pull the information from S3. And because it pulls the information from S3, it's going to feel and look like normal storage. So let's map this out. Let's look at it architecturally, visually. You got your information. It's here. You want to pull information. You go to what do you call it? Your VM gateway, and it pulls it from the cloud for you, and then sends it back. Now see what's going on with this VM gateway. It'll actually cache things. So let's say me, Alonzo, and Ned all wanted to go for the same file. Let's say Ned got it first. Ned's the first person that pulls the file. It'll be pulled from S3, sent to the VM gateway, and then sent to Ned. Now me, I want to go access this file, but Ned already retrieved it. So I'm going to go straight to the VM gateway, and it's going to send the information back to me because it's cached. Now 5 minutes I requested, after I requested, Alonzo is going to do the same thing. And guess what? He's going to go and he's going to get his information directly from the VM gateway, and it's going to be sent to him like it's cached. Does this feel familiar to anybody? Does this feel a little like CloudFront or caching on databases? It should. Same kind of technology. So these are the kind of things that I'd like you to know about. So at least understand those kind of concepts. VM gateway cache mode, predominantly if your stuff is stored in the cloud. But you can migrate stuff to the cloud and pull stuff from the cloud, and any of these VM gateways, they allow for bidirectional communication. Now let's talk about high security connections to the cloud. As a rule, if you're using a VPN, you need to run IPsec because you need to secure it. But what about if you've got a direct connection? Generally speaking, with a direct connection or a wire between you and the destination, people typically don't encrypt it because it's private. I mean really private. So in other words, let's say you wanted to try and find my internet traffic. Well, not my internet traffic, my private traffic. What you'd have to do is go underground, find my fiber optic connection, cut the cable, put a special tap on that, polish off both ends, on the tap connected to a sniffer to be able to see what's going on. Is it possible? Sure. Is it common? No, it's a private line. But if you wanted to, you can still run IPsec over your direct connections, and that's how you can create even higher security connections. You can always run IPsec on a private connection to further enhance the security. So when we're talking about direct connections and VPNs, I want to just cover one concept since we're dealing with these clouds. You can connect to public and private virtual interfaces. So when you've got VPNs, direct connections, any of these kind of connections going back and forth to the cloud, look at it this way. You can create what's called a public and a private VIF. So your private, which is spelled improperly here, which is the top one is a private virtual interface, and that's going to go to your VPCs. Now your public virtual interface would go to public services such as like DynamoDB, S3, or things like that. So what you can do is you can actually set up a public and a private virtual interface to be connecting your things from the data center to the cloud. Apologies here, the top one where you can see going the VPC subnet is actually a private VIF. I give napkin sketches to some very talented people and they redraw things for me, so occasionally we run into these issues. Like in this case, it should be private versus public. And the bottom, which you can see, which is going to the VPN gateway, is going to public services such as DynamoDB and things. And that's why you can literally set up your direct connections, public and private access to access different endpoints. We're going to talk about one more architecture here, and that's going to be transit VPCs. So what if you wanted to connect your data center to multiple VPCs? And there's a couple ways you could do this. Previously, we talked about doing it with cloud, like using the cloud, and ways you could do it with Cloud Hub, and we'll work through those architectures. And then we talked about if you're connecting like a data center or a VPC to multiple kind of things, what you could do is you could use Transit Gateway, for example, if you wanted to use private lines, Cloud Hub for VPNs, Transit Gateway for private lines. But there's another way you can do these kind of things. Let's say, for example, you wanted to provide transit and service. You could create something called a transit PVC. And this is basically what enable your VPCs to talk to each other. So realistically speaking, architecturally speaking, what this is going to look like is you've got an environment, you're creating this VPC, and the transit VPC is going to provide services to your users and your customers. So pretty simple way to do it. You create your transit VPC, and your users are coming to access the information that's coming from you and your transit VPC. Not much to talk about there, just architecturally one more thing to think about. So we're going to talk a little bit about billing for network services and that kind of things that people pay for. That's next. But prior to getting into that, I just want to make sure that there's no questions because we're changing topics. Let me know if you guys have any questions. If there's no questions, type the words and I'll be a good steward myself. Cloud Architect below, and I know you're ready to go. Let me know if you're ready to go to the next section and we'll move on. If you're enjoying this, please leave a like, subscribe to the channel, and hit the bell to be informed of new services that we're doing, and share this content with others. We're not going to have a deep discussion on billing, but I do want to make sure we cover it. Alonzo, I know you're covered. Good, thank you. Is everybody else there? There's about 60 people on the call, so I want to make sure that everybody's good. If you're good, let me know by saying Cloud Architect. Ian, you're good. 4D Robotics, good. Cloud Hub Arun is exclusively for VPNs, where Transit VPC is different. Cloud. Now, if you're talking about Transit Gateway and Transit VPCs, well, now you're getting into more similar things. But a Transit VPC is to provide a service. A Transit Gateway is to provide connectivity to different environments. I see that some of you guys are awake. I see that Chris is awake and good. Ned, Derek, Alonzo, and Ian and 4D Robotics are good. Before I go on, I was kind of hoping to know that everybody's good, so let me know. Okay, Stu Clip, I know you're good. Silence generally scares me because that makes me not sure if people actually know it or not. So let me know if you're ready for me to go on by saying Cloud Architect below. Then we're going to get to some billing. So, because billing with AWS is a little different than everybody else in the entire world. So, it's feeling a little quiet. I'm going to go back to speaking and teaching then. Okay, I see some questions, so good. If you use a volume gateway in case of disaster recovery, how does your EC2 access the data? Maxim, that's a good question. Well, it wouldn't work that way. So Maxim, if you're using the volume gateway and you're basically copying your data over, you're going to have machine images and things like that. So you're going to have to launch them. So if you're using the volume gateway to copy it over, it's going to be a lot like disaster recovery option 1, Maxim, where basically you're going to have copies of your machines, and it's going to take you a good 12 hours to turn all your data back into machines at minimum. So it's not really a great way for disaster recovery. It's more of a way to start migrating your stuff to the cloud or using the combination of both on the cloud, Maxim. Okay, so Arun got the transit gateway versus in-transit VPC being different. Okay, perfect. Maxim, we answered your question. So let's go to the concept of billing. Now, when you're dealing with the cloud, billing is totally different. See, in a normal environment, you pay once, and then you just pay to use. You just pay your electric, your network costs, things like that. But when you're dealing with AWS and networking, it's totally new. So typically speaking, let's say I wanted to buy a private line from New York to London. I wanted a private connection between Ian's house and my house, because I spent a lot of time talking to Ian. And I wanted to use this private connection. Great. So I've got a private line. I pay for the Palm Beach to London, UK private line. I pay one fee, and that's the fee for the connection, and that's it. Now I may pay a fee for the local loop and a fee for the long distance haul, but I'm paying for one connection. Now with AWS, it changes everything. You got to pay for your WAN, which could either be your local loop plus your WAN, or it could just be your WAN, just like before. But now, not only do you have to pay for the connection, you have to pay every day that your connection is up. So you're not just paying to have the connection, you're paying actually for the connection to be there. And then you're going to have to pay to use the connection. So normally speaking, you buy a connection and it's done. But no, not with AWS. Not only do you have to buy the connection, you have to pay a port fee, basically per hour, and then you have to pay another fee to actually use the thing that you previously bought from somebody else. So this gets really ugly. So does this make sense to be on the cloud? I don't know. It's up to the cloud architect to determine, is it cheaper to pay all these fees to migrate to the cloud and use it, or is it cheaper to stay in the data center? Now I'll tell you, for the average customer, it's typically a bit cheaper to be on the cloud, but not for everybody. So that's the job of the architect. So what does AWS build for? 3 components. The service fee, which is a port fee per hour, a data processing fee, which basically anything that's going through a NAT gateway or a load balancer, and then data transfer charges, which is basically anytime you're using your thing. So let's talk about service and port hour fees. If you've got a VPN connection, every hour your VPN tunnel is up, you're paying for it. And any outbound data, meaning outside of your VPC, you're going to pay for it. The only thing that AWS doesn't charge for right now is inbound traffic, sending them data. It's not a cost to send them your data because they want you to be on the cloud. They only charge you to take it off. So, you know what's charged with a VPN. How about a direct connection? For every hour the direct connection exists, you're charged. And any outbound data, you're also charged. So understand this. Now, understand this, that your outbound data charges on a direct connect are often cheaper than a VPN. So while a VPN is cheaper than a direct connection, if you actually use the VPN, it might be cheaper to have a direct connection. So not only is direct connection better in terms of performance, faster because it's guaranteed, lower latency because it's guaranteed, less jitter because it's guaranteed. If you actually use your connections, it might be cheaper. So understand that. Now, there's other things that AWS charges for it. Remember we talked about instead of VPC peering, you can use private link, which is a great way to connect VPCs to each other. So every hour that an interface endpoint exists, you're going to pay for it. And you're also going to be charged for any data that goes through your VPC endpoint. So understand that. Now, if you're dealing with a NAT gateway to provide egress-only internet access to your systems to update their patches and their operating systems, they're going to charge you for the NAT gateway as long as it exists. Plus, there's a charge for the traffic that goes through your NAT gateway. So pretty much, you pay to have it, and then you pay to use it. So AWS is the only environment, plus the cloud providers, not only to pay to have something, but you actually pay to use them. So when you're an architect, and you're trying to design a system for your customers, just paying, 3 times different things, is it cheaper than being in the data center? I don't know. Depends on the architecture. Sometimes the clouds can be 50, 60, 70, 80% cheaper. Sometimes it's more expensive. What are the use cases? Like, a lot of people ask me, what's the best certification? I'm like, for what? For example, to be an architect, to be a sysops person, to be a DevOps person, to be a network engineer. I don't know. You tell me the career and I can give you the best certification based on your goals. Same thing here. Better to be on the cloud or the data center. What's the goal? That's why the architect is not just a configurer. They're a business person. They're a partner. They go meet with those clients. They find out everything the client's goals are. What are you trying to achieve? Where's your future? What are your pain points? What's the regulatory environment like? You can't design anything without that. That's why you have to teach that. Well, that's why it's impossible to be an AWS Certified Solutions Architect professional and still be a cloud architect if you don't know how to do those skills. They're critical skills, and they're not taught in that curriculum. These are architect skills because you've got to be able to figure out what's best for your customer. Same thing happens with the cloud. Is it better, faster, cheaper? Sometimes. Is it more expensive, slower, and more expensive? Sure. It's all based on the use case. So that's why you as an architect need that business acumen, need those communication skills, and need the overall vision. And if you're bogged down with Python or sysops or DevOps, you're not going to be in the position to be thinking of these things, which is the job of the architect. So just understand that. That's why we're focused so much on architecture. So now let's talk about some more fees that exist. So let's say you've got a load balancer. So you're going to pay Elastic Load Balancers fees, which is basically a charge for the number of hours that the load balancer is in operation. But, you're not just paying to have a load balancer, now you're going to pay to use it as well. And you're going to be charged with load balancer capacity units, which is a combination of traffic flows, bandwidth uses, and a number of rules based on the load balancer. So the more complicated your load balancer policy, again, the more you're actually going to be paying for these things. So let's talk a little more about these things. Let's talk about data transfer charges. If you're going to send any data to the internet, outbound traffic, it's going to be billed. If you're going to transfer data from one region to another, it's going to be billed in both directions. So this is where, for example, if you had a website that's in 2 locations, you might think about synchronizing your S3 buckets. So you're not paying for international transfer charges every time a website request is made. That's why you might be doing it. Now, if you're using CloudFront, there's going to be a charge from outbound data to X locations to your customers. So realistically speaking, understand there are a lot of charges when it comes to the cloud. So when you're designing an architecture, you're going to think of these costs, and you're probably going to have a costing team help you build it out. There's tools that are there to help you figure it out. Now, I'm not going to say they're going to be the most accurate things, but it's going to be, any tool is only going to be as good as the source of the information. If you know exactly how much data is moved in and moved out per day, and you've got good use of your systems and good use of your network and good data, you're going to get good information. If there is not, you're going to be figuring out as you go along. So the better information you have, the better. Now, there are websites that determine what you pay for AWS. I recommend you go to them every time. This stuff changes constantly. I will never commit this stuff to memory. It could be different tomorrow than it was the day before that. Got to go to the website. There's tools in the AWS website that literally help you calculate everything. Now, when you're dealing with this kind of stuff, you could be getting into some pretty big bells. So especially when you don't have good data ahead of time, if you don't like surprises, and I'm not the biggest fan of surprises, realistically speaking, what you actually have to do is you're going to have to set up a budget. And you can set a budget that basically says at 50%, send me an alert. And the budget isn't going to stop your spending, It'll at least let you know what's going on so you can plan better and maybe buy services that are lower cost because of volume pricing or things like that. So just think about that. Now, there is a concept of an automated tool called AWS Trusted Advisor. I'm going to introduce the concept. I've never seen an automated tool like this in my entire life ever really work properly. So understand that. But what do I mean by this? What's going on with Trusted Advisor is as following. It's a tool to basically help an organization optimize their spending. And what's going to happen is it's going to scan the infrastructure and it's going to compare the infrastructure to best practices and make some recommendations, which should help improve performance, security, availability, that kind of thing. And of course, there's two versions of Trusted Advisor like anything else. For individuals that are on the basic and developer support plans, they're going to get 6 security checks and 50 service limit checks at the time this course was made. And for organizations customers on like enterprise support plans or business support plans, you're going to get a lot more of these. They'll get 115 Trusted Advisor checks. Of that, 15 are related to cost optimization, 17 are security, 24 are related to fault tolerance, 10 are related to performance, and 50 are related to service limits. But understand this, it's a tool. Any of these tools, cost explorers, budgets, Trusted Advisor, they're tools. Don't count on them being super accurate. They help. A lot of this stuff is still manual to really be accurate. So we discussed a little bit about costs. And let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's talk about building some high availability systems. And then we're going to get into some fun. So what is availability? Availability just means, are the systems going to be there when you need it? That's it. So if a system's never there, it's got an availability percentage of 0. Now, when you're designing for high availability, you have to figure out what happens if users can't access the service. That's the determination of your architectural design. If someone's going to die if your systems don't work, they need to be up all the time. If, for example, I'm running a retail store in my home village in Greece where people work 7 to 11 and then they nap, and then 2 days a week they go back to work for 2 hours and the rest of the time they're napping and partying and going to the beach, and the systems are down when people are napping, it's not a problem. But if I'm running a healthcare organization and all my patients' medical records are electronic and I can't access the records and somebody's having a problem and I need to do emergency treatment and I don't know anything about my patients, someone could die. When you're dealing with a bank and they're processing a certain number of trades, a minute of downtime could cost millions or worse. So availability matters. So the availability or the performance of your systems, meaning how likely they are to be up and available when you need them, is going to be based upon the business needs. Again, this is why you got to ask those business questions. This is why an architect is not an engineer building it. They have to ask these questions. What's critical to the business? So when we talk about availability, we're really talking about things between 99 and 100%. And with that determines, how often people's systems are there. So who needs what? Most organizations can get away with what you'd consider 4 nines or 99.99% availability. Now, not good enough for bank at all. Not good enough for a hospital at all. Good enough for most. Guess what? You can get to 99.99% available by using a great design across 2 availability zones. And that's the best you can do. You want to get beyond that? You're going to have to use multi-region and multi-availability zones. Who needs 5 nines? Service providers, banks, and healthcare organizations. Who else would want it? A company like Amazon. Both because they're a service provider, but you think Amazon wants their store down for 10 minutes, 20 minutes, 30 minutes at a time, how much money are they going to lose? So they probably want 99.999% as well. Likewise, smaller offices might not need it, so just start thinking about that. So what do these numbers actually mean? So here's a chart I made for you guys to really look at it. A system that's 99% available, well, guess what? You're going to be down on 3.65 days per year. I don't know any organization that can tolerate that right now. What about 3 nines or 99.9% of the time available? You know what? That's probably your internet access in your house. Which means if you're using a VPN from your house, you're never, ever, ever going to get better than 3 nines at best, because that's your internet access. Now 4 nines. 4 nines, which is what most organizations would consider high availability, basically gives you 52 minutes of downtime per year. So that's less than an hour. Not that simple to achieve. Most organizations don't have the sophistication to do that, but it's easy. And in the cloud, it's much easier. 4 nines in the data center takes some pretty smart people to do it. Even 4 nines in the cloud takes some pretty smart people, but it's harder in the data center. Now, when it comes to 5 nines, this is relatively challenging to do. Those of us that can do it have been around for a long time. Only people that know how to do 5 nines availability are really good networking people. The networking is the foundation of these systems, and you're dealing with, typically to get to 5 nines, you're dealing with Cisco certified internet experts like me, and then they need to be working with really great application people, really great Linux people, and really great other people, security people on a big team to do it. Because, it's not just the network, it's the servers, the load balancers, and all of it. So to get to 5 nines, you're dealing with some pretty capable people. And if you're on the cloud, what are you dealing with? 2 availability zones and in 2 different regions. So that's how hard it is to get there. Lots of change management. We can talk about change management. Change management is, before I make a process change, I have to ask every other stakeholder in the organization, will what I do affect you? Because if it does, I have to do it at a time that won't affect them. 5 nines availability means 5 minutes and 15 seconds of downtime per year. Think about that. 5 minutes and 15 seconds of downtime per year. What if you wanted to reboot your server 3 times? That uses it all. So think about that. Now you know why high availability systems are built a certain way. So what goes into this? Well, there's a military adage. 1 is none, 2 is 1, and 3 is better than 2. What do we mean by that? You can never have 1 of everything. It will fail. And you know what? 2 is often not enough. You really need 3. But at minimum, you need 2, because 2 counts as 1. So no single points of failure. This means redundant power, redundant cooling, redundant network connections, redundant routers, redundant switches, redundant servers, redundant load balancers, redundant DNS, redundant storage, redundant applications, redundant databases, redundancy everywhere. If you don't have all that redundancy, guess what? It's not going to work. Now when it comes to routers, you're now dealing with more important things. You're looking for a high availability router. What goes into a high availability router? Redundant power supplies. Redundant control modules, like basically the CPU or the brain. Stable firmware. This goes into a high availability router. Wow. Redundancy everywhere. So line cards, basically speaking, if a card fails, your router's still up. If the CPU or memory of the brain part of goes, it's done, the power supply goes, they're still up. Still, not only do you need redundant of those routers, because 1 is still not enough, even if each one is really 2. So redundancy in high availability routers. Now this is easier when you're with AWS because they maintain redundant power for you. They also maintain redundant cooling for you. They've got redundant network connections, redundant routers and switches everywhere. So when you're dealing with the cloud, the complexity to design 5 nines for a network architect like me is reduced by 50% because most of the stuff is done for you. Remember, it's a virtualized network in a data center. Because it's a virtualized network and data center, if AWS does it right, you won't have problems. But if AWS does it wrong, you're going to be affected by them. So good, bad, and different. Who's a bigger target for being hacked? You and your data center or AWS? Who's bigger? The bigger the target is, the bigger the hack risk. So not like AWS isn't secure. I don't want anybody to think I'm saying that. I'm not. But why do Windows systems get hacked more than Mac systems? Is Windows less secure? No. It's still secure. Why does my Mac get hacked less than a Windows system? 80-some% of all computers out there are Windows. If I'm a hacker and I'm going to develop software to break into something, am I going to basically go for the most bang for my buck, which is Windows? Or am I going to focus on the small percentage of the computers that are Macs? I'm going to go for Windows. All businesses run on Windows. I'm not going to be worried about the graphics artist stuff. I want the big data center stuff. So that's why systems are done. So just think about these things architecturally when you put them together. So let's talk about building for redundancy in the cloud. If you can tolerate 99.99% availability, what do you need? Multi-availability zone. And that means that anything that needs to be highly available needs to be redundant across availability zones. Virtual machines like EC2 instances, containers, databases, load balancers, DNS, everything's going to have to be split across 2 availability zones. That, plus good change management, plus good architectural design, plus good security, and multi-AZ can get you to 4 nines in the data center. Now let's talk about your high availability networking. Now, in the cloud network stuff is taking care of you where your systems are. But it's not your connections to the cloud. So what could that look like from an architectural perspective? Let's talk about it. Architecturally speaking, these again are going to be different. Redundant network connections from the data center to the cloud. Direct connection, backup direct connection. Direct connection, VPN backup. You can't just have one connection and nothing. Because this connection will go down, and when this connection goes down, you've got nothing. You've got nothing, meaning all your systems are down. So you need at least 2. 1 is none, 2 is 1, and 3 is better than 2. So, multiple connections to the AWS. What's it going to look like? Primary direct connection, backup direct connection. Maybe you're using link aggregation groups where you've bundled 4 cables in a single connection. If you need 4 10 gig links on your primary connection, you need 4 10 gig links in your backup connection. So your backup has to support your needs. Now, when you're dealing with redundant connections, let's say you've got an AT&T one and a Verizon one, get them on different service providers and make sure no part of this is the same. Not even the local loop coming into your building. And if you're not sure what I mean by a local loop, I'll let you know. So these are the ways you can start thinking about these things. So that's the way I would start looking. Now when it comes to security, you got to lock your systems down. If your systems are not locked down, guess what's going to happen? People will hack them. So start thinking about systems. So first start with the principle of least privilege, or the military adage, need to know. Do not give users access to more information than they need to do their job. Somewhere along the line, you'll get hurt and you'll get hacked. Now let's talk about your systems themselves. If you've got a web server, what should your web server doing? Web serving, nothing else. If you've got a web server, disable all unnecessary services. The only parts your web server should be listening to are port 443 if you're dealing with HTTPS traffic, or port 80 if you're dealing with www traffic or traditional web traffic. Nothing else. Ideally, you disable SSH even on these servers. If you have to, make sure that SSH is allowed, but you're blocking it with like a host-based firewall and/or a security group and a network ACL to allow only that in from a specific host. Don't allow blanket open SSH. Things will happen. Now on these systems, so first, only enable the necessary services. Use the principle of least privilege or need to know with regards to user accounts. Patch these systems. Make sure they're secure. There's going to be a security vulnerability. Patch that thing. Now, how else are you going to further secure your systems? Remember earlier in the presentation we talked about organizations and AWS organizations where you could basically take your environment and you could chop it up into little mini environments and allow a policy called the secure control policy between them to make sure that what happens in one doesn't affect another. And we call that limiting blast radius. So that's also part of your building your high availability, high security systems. Keep unwanted traffic out of your systems, which means, and we'll do some architecture work soon, at the perimeter of your network, outside, firewall, block all the bad guys. And you know what? Like a castle has got a big wall, and it's got this moat full of alligators and sharks and all these other scary things, and there's knights behind it. You need a firewall to keep people out. Right behind the firewall, you're going to stick an intrusion detection, intrusion prevention system. It's like an SAS commando or a Navy SEAL or a MARSOC Marine that's sitting there behind the firewall, and if anything gets through, it's going to take it out. That's how you secure your systems. Behind the firewall, you're going to protect your subnets. How are you going to protect your subnets? You're going to use a network ACL. And how are you going to protect after the network subnets, people getting in your system? You're going to use a security group, which basically says it's almost like a host-based firewall. But you know what? Add a host-based firewall too. What else are you going to need to keep your systems locked down? Physical security. What does that mean? If somebody walks into my garage right now, which is highly locked down, but if they were to walk into my garage, they'd see my firewall, which connects to the internet and my VPN concentrators. Which means if someone could break into my garage, they can get onto my systems. got lots of security in my garage, but that's neither here nor there. But physical security, I can't just leave it so that somebody can walk in my house, plug in, and be on my network and access my systems. That's obviously a problem. If you need to use passwords, use strong passwords, and template all good known configurations to your systems. Why? When you've got a system that's not properly optimized or patched, it's going to be vulnerable. So, if you're one of those people that's used to using CloudFormation templates, create a template or have one of your sysops people create a template that's designed to basically launch something that's approved and known to be good, strong, and locked down. So, those would be the ways that I would recommend doing these things. Now, of course, when you've got these systems, no system, no matter how good it's going to be, is really going to be functional without backup. Systems will go down. That Murphy's Law, anything bad that can happen will happen. Trust me, I promise you, it will happen. So make sure you back up your data quite strongly and provide your data in multiple environments. So if something happens in one place, it's backed up somewhere else. When you back up, at least one additional location securely. Your servers, make backup copies of your servers, and after you make backup copies of your servers, store them somewhere. Same thing for your router configurations, your switch configurations, your firewalls. Everything you're doing here, 100% of everything you're doing here, is really related to one thing: being up and available when services are needed, and when you're not up and things break, because they will break, getting them back as fast as possible. So let's talk about performance. How are we going to scale these environments, create more availability, and improve performance all at the same time? Well, for those of you that know me, you know that I love the data center. But you also know that I love the cloud for the appropriate use cases. But you know I love the data center. I'm really not sure what's going on with my camera here. Hopefully we can fix the focus issues for you. There we go, that looks better. So, what I like about the cloud is the auto-scaling concept. Normally speaking, off the cloud, you buy your server capacity for the busiest day of the year. Not here in the cloud. We're going to basically be able to buy the server capacity for average, and we're going to add servers as needed with auto-scaling. It's going to happen automatically. If there's a cost saving to be achieved in that cloud, it's from auto-scaling. So we're going to use that as part of our high availability, high performance systems. What else are we going to do to make our systems more robust? We're going to decouple our application architectures. Why? Let's say we've got a web tier, an app tier, and a database tier. Let's say the stuff's coming in through the web tier, it's doing great, it's hitting the app tier, and on the way to the database tier, there's congestion. We can't lose performance, we can't lose orders, we can't lose data. So we're going to add a queuing system like an SQS queue. We're going to further reduce load on the system by using caching. We use load balancers. Anything we can do to remove single points of failure, that's what's going to go into high availability systems. So now you know how to build them, but guess what? We've got to monitor these things. We're going to use logging and auditing functions. We're going to be looking at CloudWatch alerts for systems alerts. We're going to look for security breaches and logs from our security appliances and Cloudtrail as well. We're going to monitor usage patterns. We're going to check our systems for performance. If our systems are teetering over 80%, you know when they're going to hit 100%, they're not going to be available. So we've got to make sure we've got plenty of capacity and plenty of performance. Now the last component of high availability systems, and this is how I know someone's worked in tech versus not worked in tech, is if they know about change management, they've worked in tech. Change management is as follows. I want to make a change to my BGP policy. I want to send a community my neighbor because I want them to match that community, prioritize traffic for a certain subnet over a certain link, or vice versa. In order to do that, I'm going to have to tear the BGP session down. When I tear that BGP session down by clearing the BGP neighbor, it might take 30 or 45 or 60 seconds for that session to come back up, be fully established, and start exchanging routing information. Guess what? It's a minute of downtime. So I need to know that if I cross that minute of downtime at 3 o'clock in the morning, that there's not a batch job running that's processing, say, a large amount of financial transactions that will be broken by my clearing the BGP neighbor. Because what if that process C has to happen and it's critical for next day's business? I broke it. I broke the system, caused a problem. So change management is the last stage. So we talked a lot about building high availability, high performance systems. So I spoke a lot so far. You guys have listened a lot so far. Let's answer some questions, and then after we have some questions, let's have some architecture fun, where we'll design some architectures for some systems in some various environments. So I'm going to start looking for questions and then ask me questions along the way. Now's your time to ask questions. So gather up your questions, ask them, and then we're going to do architecture fun. Let's see which questions we have. Eric, I'm so happy to see you join. So Arun, budgets get set up with AWS budgets, and it sends an alert. CloudWatch is more of a logging function, but budgets will actually send the things. So, and it's going to be a lot like what you're dealing with GCP, but it's actually coming from the budget section. So the IDS will work as a firewall. Okay, so there's basically two kinds of IDS IPS systems going on. Traditionally speaking, and we're going to map this out in a minute, we're going to draw it all. You've got a firewall, and then you've got an IDS IPS system. The IDS IPS system doesn't just protect an EC2 instance, it will protect the entire system. A firewall keeps bad guys out and doesn't allow anything in. It allows your traffic out and your return traffic back, but it doesn't allow anything else. By comparison, an IDS IPS system is just monitoring. Think of it as a commando. It's sitting there, it's looking around, what's going on here, what's going on here, what's going on here. It's just watching. Whoop, this pattern behavior is bad. I'm going to drop this right now. Bad behavior. I'm going to reset a TCP connection. I'm going to set up a network access list. Just sitting here looking around, what's going on. I see it, I'm going to attack it. That's your IDS IPS, Mr. Sharma. Let's see. Okay, I'm kind of looking to try and figure the next question is from Arun. When should the AMI and snapshots as creating disks consuming work? Creating disks using snapshots or time consuming? I don't completely understand your question there, Arun. Basically speaking, if you make a machine image of something, it's just a snapshot. And then you can launch it in literally a matter of seconds. When should you use AMIs and snapshots as creating disks using snapshots? Or I'm still not sure I understand your question, Arun. There's something that's so when should we use AMI and snapshots as creating disks? There's something I'm really missing there. It's not like a complete sentence. So could you kind of like tell me exactly what you mean? I'm not trying to be difficult. Or Arun, since you're one of my students, you can ask this question on Slack if you like, and we'll definitely answer it, or answer it on the Monday or Friday. But I really would like to answer your question if I actually understood it. So if you create a custom, if you take so the reason I think I'm not understanding it as Arun is as follows. So let's say you take a base AMI and you customize it and then you save it. That's a custom machine image. This is what you're going to save in your disaster recovery environment. It's going to be a custom machine image of your own systems. So a snapshot of that is the same thing. Exactly, it doesn't change anything. A snapshot that you're going to create is going to be a custom machine image of your own system. So it's kind of one of the same. That's why I'm not really sure what your question is. Now, Derek's question, that's pretty simple. As a cloud architect, are you going to document change management? Not really, and here's the reason why. As a cloud architect, you're the systems designer. And you're not going to be making changes. You're not going to be hands-on on these boxes. You're not going to be touching them for the most part. So as a cloud architect, you're going to design these systems and make sure the engineers put them in place. As a rule, these changes that occur are going to be sysops, which is more maintenance. So cloud architect, system designer. Cloud engineer, system builder. SysOps, the maintenance man or woman, whatever term you choose, maintaining the system, so scripting and lots of automation. DevOps, automating software release cycles. So, do not, if you want to be an architect, study SysOps or DevOps, because they're competing careers. It's going to make your resume look terrible. If you want to be an architect, study architecture. What is architecture? Cisco Certified Design Expert, Certified Solution Architect Professional, TOGAP, architecture certifications. These are architect things. So just kind of make sure that you're going down the right pathway. So no, you're not going to be doing too much job change management as a cloud architect, Derek. Great question in every way, shape, or form. But as the leader, you might be the designer, so you might be a part of the process, so you'll still have to be part of it as a stakeholder. Nick, you missed one of the billing types. Okay, let's go back to the billing section so that I can talk about those things that you're basically being billed for. Great question, Nick, and thank you for confirming. Basically, the fees that you're being charged for as follows. They're service fees or port fees. Basically, if you've got a system and it's up, they're going to charge you for it. They're going to charge a data processing fee, basically for any kind of data that's used on a NAT gateway or a load balancer. And then they're typically going to charge you a data transfer fee, which is anytime you send your data out of the AWS network or across regions and things like that. Nick, I hope I answered your question there. Arun, I hope I answered your question, but I'm not completely sure. So Arun, if I didn't completely answer your question, please just retype it in a different way. I know you really well, Arun, and I think a lot of you, so I want to make sure I get that question answered for you. Derek, you got it. Good to go. Any more questions for me? Because if there aren't, now we're going to get into the fun. So if you want to type, if you want to start doing some cloud architecture work together, type solution architect design work in the chat box and we'll start doing some design work. Amit, you're good to go. Perfect. Let me know if you guys are ready for architecture fun by saying solution architect design work in the comments section. That way I know you're awake, alert, and oriented and ready to go. You guys here, or am I just dealing with a very long delay? There's 60 guys there. I'm only hearing from 3 of you guys. I want to make sure you're there before we start moving on. We know you guys are there. We're going to start having some real fun. So let's start mapping out some simple situations, and we'll get progressively complex as we want to go along. Now that's a question, Derek. When you're the cloud architect, especially the lead cloud architect, who's going to really check your design work as whether it's right or not? Ooh, that kind of means you. You are the lead or the designer. So one of the reasons when we created the Cloud Architect Career Development System, we created all these communications and collaboration platforms, and we took students from all over the world, and I interview all these people to make sure that everybody's capable and knowledgeable, is you're going to have to build a really good team to go with you. And your team, when you get stuck on a question, you're going to be asking. So for me, a network guy, and a data center guy, and a security guy. When it comes to applications, I go find an application architect. I'm going to ask every single time. When it comes to databases, I'm going to ask a database architect every single time. And you know what that database architect is going to know when it comes to networking? They're going to be like, Mike, there's this routing thing, and I don't get it. I'm going to be like, perfect, I'll tell them the routing thing. And when there's an application thing, I'm going to call one of my friends that's an application architect. Hey, call me. This is an application thing. I don't understand how any of this works. And that's what you do. You build yourself a team. So learn enough about everybody else's career to be able to handle a meeting and be great. Be really great. Be the best you possibly can be at your own field, and you'll be doing things grown. So, perfect. So let me just check and see. Arun, they're the same thing. If you create a snapshot of your computer, it's going to be identical to a custom VM that you actually make. Your snapshot is a full version, so it's one of the same. So if I create a web server, for example, and I create a snapshot of my web server the way it's designed, with my own security policy and all my things done, it is my own custom machine image, and it's the same thing as if I create one. So the snapshot and the custom machine image is going to be the same. That's why I couldn't understand your question. Malik, how are you, mate? Okay, so let's do this. Let's start first with creating a web-based application. So let's say we're in our VPC. Let's get rid of some of these colors in the center of the fill. Okay. Yes, Alex, I couldn't agree more completely with you. The secret of success is knowing what you know and knowing what you don't know, being able to build a team and a network of all the right people that can support you throughout your career. You support them throughout your career, and you become great at what you do, and you help others become great at what they do, and that's the way to do it. So yes, build your network of people, telecommunications gears, all of it. Arun is different in GCP, but in AWS they're basically the same. So let's say you've got your normal environment of a 3-tier web app. What's it going to look like? You're going to have a load balancer. We'll call it an elastic load balancer because we're doing AWS today. Normally my guys and girls do every cloud in the world, but today we're just going to do AWS. So we've got load balancers. We're going to have a web server. Let's say we'll have a load balancer. We'll have an app layer. And we're just going to do single availability architectures to just make life simple right now. Then we're going to do a database. Oops, didn't mean to do that. Hit it undo. So let's say we're going to use a relational database and we want this thing to scale. So let's set up our database structure down here. So let's say, for example, we're using a relational database. Let's say MySQL. Because it's common and everybody uses it everywhere. So let's say we've got a MySQL database. So let's say we're drawing out a basic simple environment, and thank you guys for reminding me. So we put a load balancer prior to our web tier, a load balancer prior to our app tier. We're going to use a MySQL database. So how do we scale SQL databases? What do? We add read replicas, and we point the read traffic to the read replicas. So that's a couple of read replicas. Maybe we'll add some caching to reduce the loads on the read replicas. Let's say we use like an Elasticache. And then let's say we reduce write load through the use of some queuing systems. So typical 3-tier web architecture. Now, how do we serve this application from the internet? Let's put the internet over here. Do we have a cloud that we can use for the internet? We do not have a cloud that's here. Oh, here we do. The internet's also generally considered a cloud because nobody knows what it is. So, now that you can see this environment, what do I need to do to make this web server available on the internet? First person, let me know what do I need in my VPC to connect this to the internet. Because my systems are there, they're all up and running. What do I need to connect my system to be reachable through the internet? We'll map out the security architecture later. I just want to know what's necessary to be reachable through the internet. Somebody tell me. What's the router that connects you to the internet called in AWS? Somebody, we just talked about routers, an internet gateway. Nice job, Lemon Sharma. Okay, great job, 4G Robotics, and you guys got it. So we need an internet gateway. Wonderful. You guys are making me happy. Not only awake, alert, and oriented, but you're doing a great job as cloud architects. Fantastic. So we're going to put an internet gateway here. Nice job. You guys are doing great, by the way. No. No, in a room we don't need to run BGP here. I wish we did, because I love using BGP, but we can just get away with the default route because there's only one access to the internet. We use BGP when there's multiple connections to the internet, so we can load share. So we need an internet gateway. Now, do we need a public IP address for the systems that are reachable on the internet? And if so, where do we need public IP addresses in this environment? Let's start. Does the internet gateway need a public IP address? Yes or no? Let me know in the comment section. And if we do, where do we get that type of an IP address on the AWS cloud? And what's it called? Guys, let me know in the comment section. We do need one at the load balancer. We sure do, Lamat Sharma. Great. So we're going to put one on the load balancer. We're going to put an EIP, or elastic IP address, on the load balancer on the outside interface of it. Where else do we need it? We need another elastic IP in one place. Does anybody know where that is? Good job, Yogesh. There's a lot of yogis on this call, Yogesh. I don't know if you're a yogi like the rest of us, but there's a lot of yogis on this call. The internet gateway needs an elastic IP address. Yes. Who is this person? We need to get this person a cigar. Nick Love. Fantastic. We need a public address on the internet gateway on the external side. So here we go. This is what it's going to look like. We're going to have a public IP address on our internet gateway, and we're going to need a default route. Where does the default route point? Where's the default route point? A route which basically says, if I don't know how to get there, send all unknown traffic to this one location. It's called the default route. Where do we need a default route to go out for our traffic to go out the internet? So we need a default route that's going to say, for everything that you don't know to go to the internet gateway and then go out to the internet. That's the way you make these web services available on the internet. Does that make sense to everybody before we do the next fun architectural design? Exactly, Caesar. You point to the gateway. Why? Because you're going to have a routing table here that's going to know everything that's local. So what's not local? What shouldn't you have a route to? You're not going to have a route to the internet. So all known traffic is going to be internal to you. All unknown traffic is going to be internet traffic. It's going to go to the internet. So that's how you set up this architecture one. This is basically routing architecture. So what is the DNS, Derek? DNS is basically mapping a name to an IP address. These systems will be completely reachable, Derek, without the DNS. You just have to enter their IP name. So let's add DNS for you, Derek. Wasn't going to put it in here because I was more focused on the actual on the technology networking, but let's add it because you're right. Let's put it here. So let's say we've got a DNS policy. And absolutely, we can talk about the EIP on the internet gateway. So let's say we have DNS. What is DNS going to do? We're going to map IP address of the website to the ELB EIP, unless we're going to use Cloudtrail or something like that, or a content delivery network. So Here we go. No. Mr. Todorov asked the question of, what about the elastic IP on the internet gateway? So here's what's realistically speaking going on. Anything that needs to be reachable on the internet, the public internet, will need a public IP address. The internet gateway is a router. A router is called the gateway. So if your router is going to be exposed to the public internet, then what's going to actually happen is it'll be exposed to the public internet, and that's where you're going to need an IP address, because you can't have a private IP address there. So I hope I answered your question. Astute clip, don't worry, this is being completely recorded. You can watch the rest of it tonight. It's been wonderful having you here. We're grateful to have you spend the time with us, and anything we can do to help you in your career, just let us know. So, that's kind of how this works. Did we answer? Does anybody have a question on this before we move on to a new AWS solution architecture? You will, okay, so Mr. Todorov, what happens with an elastic IP is as follows. You will do this. You're in an environment where you borrow from AWS a public IP address you borrow one from them from the IP address pool. That's why it's called an elastic IP address, and you manually assign that address to your internet gateway. So you're actually doing some of that. Gosh, great question. Why does the elastic load balancer need a public IP address? The web servers need to be reachable from the internet, which means that web servers actually need an IP address. So what's going on is you're not really planning your web servers, the DNS to your web servers, because DNS is designed to map a name to an IP address, or maybe a name to 2 or 3 different IP addresses, but it's not designed to load share in a high performance manner. So what's going on, the reason you need to put the IP address on the load balancer is because the load balancer is so the load balancer is going to have 2 sides. It's going to have an outside of the load balancer, which is where the public IP address is going to be, and this is going to be what's seen to the internet, the external side of the load balancer. Now the internal side of the load balancer is going to be on the subnet where your systems are. So your load balancer is going to be dual homed. It's getting to the public subnet, which is going to be what's seen by the internet, and the private subnet where the servers actually are. Yeah, you have to attach the IP address to the internet gateway. So you wiki, just wondering an ELA being not a load balancer. Well, great question there. AWS does not give you the opportunity to do a straight application load balancer. With AWS, you have the opportunity to use a network load balancer or an application load balancer, but they're both called elastic load balancers. So we're going to pick an elastic load balancer and then to determine an application load balancer versus a network load balancer. Now, how do you determine, ELWiki, which kind of load balancer to use? Look at it this way. If you've got really high performance needs, you use a network load balancer. If your needs are low performance, you use an application load balancer. Performance network, low performance application. Low performance thing like routing between microservices, application load balancer. High performance, network load balancer. So that's how you're going to figure this out. In this case, we didn't really talk about the performance of these servers, so it's up to picking out the appropriate one for the use case. Everybody ready for the next one? If not, ask me the questions and let me know. If you guys want a security architecture, type cloud security architecture there. You guys, everything that needs to be reachable on the internet from the internet has to have a public IP address, which means if you didn't have a load balancer, the public IP address would be on your servers. But since you're using the load balancer as the front end to your services, that's why you need to use a public address in your load balancers. Nothing is reachable from the internet if it doesn't have a public address and it isn't attached to the internet. So your internet connection or your attachment to the internet so your internet connection to the internet is going to be as follows. That's your WAN link, and that's going to be attached to the internet gateway. So that needs to be there, but of course your web servers also need a public address, and that's why you're putting the IP address in the load balancer. Okay, I'm seeing cloud security architectures come in. So you makes a good question. So let's now pretend these load balancers were two core servers. 2 cores. That will be a low performance web environment, which would be perfect for an application load balancer. Now let's pretend our web servers, of which there's 50, have 128 cores. Big, powerful, strong servers. There's no way an application load balancer can meet this kind of performance need. So that's what you're going to do. So you, Wiki, you're going to be looking literally at the performance capacity of your servers, and that'll help you determine the performance capacity of the load balancers you need. So now let's start talking about high security. Let's keep the same application environment, but now we'll build security. We're going to work from the outside in. And I'm going to not be able to do this without asking for everybody's help. So you guys are going to have to help me, because I need help to do these kind of things. I want you guys to exercise those cloud architect mental muscles. So if at the edge of your network, I want to keep bad guys out. I want to allow my traffic out and my return traffic to come in, but I want nobody allowed in. I basically want like this giant door at the edge of my network, like a big wall that says nobody's allowed in unless I want them in. What's this thing called? A room, we're going to cover a security group right now, while we're waiting for everybody to tell me what the thing is that I need to protect the perimeter of my network. And while I'm waiting for those things to be answered, Arun, for people telling me what that network device is, NAT is used anytime you need to translate one address into another address. So if a company buys another company and they're using the same overlapping 10.x address space, that's when we basically need to use NAT. If we're trying to connect our systems that are private IP address to go out to the internet and collect things, then again, we're going to be using NAT. So NAT's used to translate one address to another anytime you need to do so. So, and Arun, if you've got questions about that, we'll take care of it. Wonderful job, everybody. You're right. We protect the edge of the network with a firewall. Perfect, perfect, perfect. Everybody's doing great today. I love this. I love when I can see that people are here, they're learning, and we're having a great time. So, we're going to put a firewall at the edge of the network. Firewall at the edge. Brutal, brilliant. Now, after we design these systems, we'll figure out where we can get them from. And I've got a security group is like a firewall at the instance level, but it's nowhere close to enough. It's not even more than 3% of the security solution. The other 97% is what matters. So we're going to use a firewall to protect the edge of the network. Now, if something gets past the firewall, we don't want that. We have to stop it. Stuff occasionally gets past firewalls. What's that called? And Alonzo, yes, we can definitely get a good firewall from the marketplace. In fact, for any high security environment, I would be getting a firewall from the AWS marketplace. Now, DDoS is another thing. We can do some DDoS protection. And should. So, we'll put some DDoS protection outside the firewall. You guys give me the architecture, I'll design it, and I'll tell you when that's good or wrong. What blocks stuff behind the firewall? Stuff that can get in. It's like dressing for really cold weather. Nice job. We need an IDS IPS system. Again, we're going to be going to the marketplace for this, yes. Probably not going to be using WAF alloc. Mr. Todorov, for a high security environment, we're probably going to be getting a firewall from the marketplace, but we could potentially use WAF. Oh, gotcha, hand to God. Well, so, okay, so we've got DDoS protection, and we can pick out a cloud module and a non-cloud module, but architecture, you don't just pick AWS services, you think about the architecture, and then you pick the appropriate services. So, how do we protect subnets? What do we do to keep traffic out of a subnet? What would that be called? Oops, that didn't mean to happen. How do we keep traffic out of a subnet? What kind of devices could we use on a router, in real networking, or in a virtual router in AWS? Guys, it's not that the marketplace is as cheap as buying direct. See, what happens is a lot of these cloud services are basically like improved versions of the Linux freeware open source stuff. And when you're dealing with high security, high availability, enterprise grade performance, you often need far better than what WAF can give you. You need something more robust. And because of that, that's why we're going to the marketplace. You guys got it. Network ACLs. Great job. Network access control lists. Well, normally we'd use an access control list, but on a router, on AWS, it'll be network ACL. So we can use that. Now, good. Now, what are we going to use to keep traffic out of the instances or the servers? After the network ACLs, how are we protecting these servers, guys, girls? Yeah, the security group. You got it. Nice job. We're halfway there. We're like halfway there now. What do we do on the servers themselves? Exactly, Guy. Anytime we want something more powerful, more enterprise, more capable than basic like freeware kind of services, or basic like open source stuff, that's when we're going to go to the marketplace, which pretty much for me is pretty much in every architecture I'm going to go design. Again, it's based upon what you're doing. If you're dealing with a small company, things like WAF and Shield are awesome. They're great. But if you're protecting, an environment that needs 5 nines, you might need something much more robust. So we got part of it. 4D Robotics got part of what you want to do on the server. So we're going to put a host-based firewall on the server. What else are we going to do to the server? That's not enough. We've got to do a lot more to keep these things locked down. I've got a web server. It should be listening on either ports 443 or port 80. What kind of ports typically are open on a Unix machine or a Linux machine if you don't tell it otherwise? If you don't know, type netstat on your system. You'll see all kinds of stuff that's open. Good job, Ian. We're going to lock down these services. So we're going to disable anything that's unnecessary. The system should only be open to what it's supposed to be. Guy Wittenhouse, the marketplace isn't compulsory. It's going to be based upon how important and how sophisticated your thing is. Derek, and Shima, exactly. We need some anti-malware. Okay, so we've done a lot to this service now. What have we done? Host-based firewalls, disabled unnecessary service, anti-malware. Anything else we do to make sure our systems are up to date, current, and not going to be and not going to have any security holes or vulnerabilities? Good job, Alonzo. By disabling unnecessary services, we closed all the ports. Great job. Fantastic. What else? How do you block newly discovered vulnerabilities in your operating system? What do we use? How do we do it? What's that annoying thing that pops on your Windows computer almost every day? Apply patches. Great job, Caesar. Fantastic. We're going to patch it. This is how you harden an operating system. You harden it by shutting off everything you're not using. Boy, I'll tell you. Don't use a very unhappy spell check. So, update management. Yeah, you're going to have to figure out a way to patch it in a reliable sort of way. So this is kind of doing this. So let's now look at this, what this looks like from a perspective of devices. What would you use for DDoS protection in AWS? There's lots of services that you could use, Cloudflare, what have you, but let's assume you're going to use native AWS services. What would you use for DDoS protection for this? Just so you guys know the AWS services for AWS exams. What are you guys going to use for DDoS? What's the AWS service called? You guys all know it. And if not, I'll help you. Excellent, hand of God, shield. Brilliant. No. We're going to use Shield Advanced, exactly. Can some of that guard duty and macing and all that other stuff be part of the thing? Sure. It helps. So now, let's assume we wanted to protect stuff from coming inside of the systems. And we're going to use an AWS-based firewall. What are we going to call it? Okay, so while I'm waiting for you guys to tell me the name of a firewall that we can use in AWS, and we're going to pick an AWS native firewall, I'm going to read Matt's question. If instances are... Exactly, Maxim, we're going to use well. So, Matt, if your instances are in a private subnet, and you're using an internet gateway, you wouldn't realistically speaking be using NAT unless you're using a NAT instance. Typically speaking, if you're going to use a NAT, you're going to use a NAT gateway that's going to allow you out to the network and then back to the network. It's going to allow your traffic out and your return traffic back, and you'll be protected. If you're going to use an internet gateway, then you could use a NAT instance and then it would be protected. But most people would use an internet gateway to actually connect their systems to be reachable from the internet. So typically speaking, think internet gateway because you want to be reachable and non-protected. Otherwise, you would use a NAT gateway. So for the firewall is WAF stuff here. We'll talk about content delivery networks later. Regarding AWS IDS IPS systems, you know, they've got some pseudo-like stuff like Macy and things like that. We're just going to go to the marketplace for this. Network ACLs we don't have to worry about, they're native. Security groups we don't have to worry about because they're native. All this host-based firewall stuff, we're going to have to get it from another vendor like Trend Micro or something like that. Lament Sharma, you can never have web servers available on the internet if they don't have a public IP address. Anything reachable on the internet must have a public IP address. The public IP address will have to either be on the web servers or the load balancers, otherwise it's not possible. If a private subnet has a route table pointing to the internet, it is still not a public subnet. Just because you have a route to it doesn't mean that your IP addresses are public. It will mean that it's completely unprotected from firewalls and things like that. Having said that, it still won't be it won't be reachable because it's a private IP, and private IPs won't be in the routing table that are reachable from the internet. So you got to really, with an IP addressing thing that's going on, private systems will never be reachable through the internet. And Palo Alto, Fortinet, Cisco, Checkpoint, they all make great firewalls. Okay, good. So now, I heard some pretty cool guidance coming there with regards to using a content delivery network. How's the content delivery network going to improve this performance? What's it going to do? Content delivery networks improve performance via which of the following methods? Derek, you brought up the CDN. So Derek, what does a content delivery network do, and how does it improve performance? I know you know why. Content delivery network speed access to content through the following means. They get people off of what? The public internet on a private network, which is faster, and they use a system of caching. So, how does content delivery networks, again, provide enhanced security? What's going on? It's going to make sure that only legitimate web requests actually even make it to the web servers. And because it makes sure that only legitimate requests make it to the web servers, it will reduce the attacks on the web servers. Well, Arif, having issues connecting to a web server that's on the internet in a non-default manner, that could literally be one of about 40,000 different things. So happy to work that thing with you together offline. So it provides caching, but it also works by keeping systems off. The real reason these content delivery networks help is they only forward legitimate requests to the server, and they can terminate SSL connections, so they can really reduce server load. So that's how they help with that. So we've got these kind of two things that are coming through. Let's talk about networking. Let's go through some of the things we talked about here. Data center. Cloud. Good job. Exactly, Derek. It's not going to forward any bad requests to the web servers. So now let's take this environment. I want to connect my data center to the cloud. What are my two options? Comment below in the chat box. I only have two options to do for connectivity. What are my two options? Come on, I know you guys know this, or I hope you guys know this. Let me know in the comment section. Direct and VPN, great. Does everybody else agree with that? Let me know. If you guys are not here, not commenting, it's because I know you guys have been saturated with network stuff, and if you guys are saturated with network stuff, we can stop the bonus architecture work. But if you guys want it, I got to know you're involved and you're still here. Exactly, direct connections and VPNs. So, now, let's say I told you that consistent latency is required and guaranteed performance is required. What am I going to choose to use? Direct connection or VPN? Okay, I told you that guaranteed performance is required and guaranteed latency is required, and it can't change. What type of connection can I use now? Well, hand of God, I'm not necessarily sure that a VPN is less secure than internet connections because it's encrypted with IPsec, which does endpoint verifications. But VPN connections provide no performance guarantees whatsoever. VPN connections are best effort. So if we need good performance, we must use a direct connection because that's the only way we can guarantee it. So we're going to do a direct connection. Let's say I need 30 gigs of bandwidth. What do? How do I make my direct connections give me 30 gigs of bandwidth? What do I need to do? How do I get enough speed to handle 30 gigs in my direct connections? Is there a such thing as a 30 gig direct connection? And where there's about a 30-45 second delay. So how do I get to these 30 gigs? What do I need? Nope, not a VIF. How do we get to 30 gigs? What speed links can you get? 1 gig, 10 gig, 100 gig. What are we going to do? Nick, nice job. We're going to create a link aggregation group of 3 groups. Perfect. 4D Robotics, you got it too. We're going to create a link aggregation group of 3 links. We couldn't really get that from a third party. Actually, the other way we could third party, you're actually correct. We could purchase a 100 gig connection and we could have a third party rate limited to 30. So that actually would be a good way to do it. That is an alternative, although I'd still rather use 3 10 gig links and bundle them together. So, you got it. 3 links bundled together in a link aggregation group. Perfect. So, if I need 30 gigs primary connectivity, am I going to survive on a 1 gig backup link? If I need 30 gigs, can I survive on 1? Or do I probably need 30? Well, if I need 30 gigs as a primary link, my backup probably needs to be close to 30. So I'm going to need a second link aggregation group, as Alonzo just said. So this is where I would build my primary connectivity to the cloud. Does that make sense for everybody? Amaranth, great job. Others. Laman Sharma, what scenario is link aggregation used? Link aggregation is very commonly used when you need more bandwidth than is available for a single link and you're looking to use simplified routing. So if you need 20 gigs and you can only purchase a 10 gig link, yes, you could load share across redundant BGP to connections, which would work, but you would typically aggregate 2 10 gig links. Gives you enhanced performance, meaning one of those links can go down and the link will stay up, and you get availability and performance. So that's when you would use a link aggregation group. But if you needed 2 gigs, or what if you needed 3 gigs, and you purchased a 1 gig connection, again, you'd use a link aggregation group and bundle multiple 3 things. So anytime you need more bandwidth than is offered by a single link is when you would use a link aggregation group. Any more questions on these link aggregation groups? I think you guys are there. If you guys want to know about VPC peering and non-transitive routing, type VPC peering in the comment section, and I know you guys want to learn about that. If you guys are tired and it's Friday and you want to say, Mike, we've been doing networking for more than 12 hours this week, I'm tired, we should end now. You guys let me know that too. I just want to make sure you guys have a wonderful educational experience and a great time. Lama Sharma, you're going to pay for 2 aggregation groups. And like everything else, you're going to pay to be up, you're going to pay to use the link, and you're going to pay for the link, then you're going to pay hourly because the link exists, and then you're going to be paying every time you use the link too. Arif says VPC peering. Cesar Gonzalez says VPC peering. What did the other 53 of you on the call say? Alonzo says VPC peering, hand to God. Nadinga says box peering. I'm good with drawing boxes. I'm totally happy to draw boxes anywhere, anytime. Alonzo, I'm with you there. It's been a long week for me, but we're talking about networking, so it's fun. Well, Guy Wittenhouse, it's not exactly like a traditional private line where you buy it, and basically you call AT&T or Vodafone or Telus or whoever your provider is, and you buy it between, say, New York and London. This is different. If you go back to, I think, day 2, where we started talking about direct connection architectures, where basically you buy a connection to a, so basically you buy a connection to the direct connect data center where your own device is, and then you pay AWS for, basically you have to do a cross connect to the AWS router, and then AWS backhauls it to their environment. The direct connection is the combination of yours and AWS's, so it's not exactly like it would be in a traditional environment. Okay, we're doing some VPC peering. Lots of people told me they wanted it, and VPC peering is cool. So if you're having fun, let us know by saying Cloud Architect. Now we're going to do some VPC peering. We're going to talk about transitive and non-transitive routing first, as we do VPC peering. Okay, so we're going to create a main VPC. We're going to create some spoke sites. Spoke 1, New York. Spoke 2, London. Spoke 3, Bangalore. You know what? I was going to use Bangalore, but I know we have at least 10 yogis here. So let's choose Mysore because it's close to Bangalore. And that's where all the, all the Ashtanga yogis like me are from. So we'll spend our time training from. So let's say we've got these VPC peering sessions over here. Let's say we've got VPC peering between New York and the main VPC, New York and London, and for all the yogis in our community, we created a connection to Mysore. Now in this environment, let's look at it real carefully. New York can talk to the main VPC if we're doing VPC peering. London can talk to the main VPC, and Mysore can talk to the main VPC. But can New York talk to Mysore? Everybody let me know in the comment section below. With normal VPC peering, can New York talk to Mysore? You guess maybe you're a Mysore Ashtangi like the rest of us. There's a lot of us. Eric is here. Eric's been teaching yoga probably for 20 years now. I've been practicing for about 15 years, and I'm a yoga instructor as well. And there's a couple of my students on here that are also yoga people. So thought we'd use Mysore instead of Bangalore. Great job! Maxim, you got it. Hand to God, you got it. Guy, you got it. Arif got it. Cesar, you got it. Mr. Todorov, you got it. None of these can talk to anybody other than the hub site. Brenda, I'm so happy you're here. Exactly. The reason New York can't talk to Mysore is as follows. AT&T does not provide transitive routing unless you do other things, which means New York's routes will be seen by the main VPC, but New York's routes will not be given to London. And because there's no routing information shared between New York and London, they can't reach each other. So if we want these devices to reach each other, how do we do it? There's two options. Does anybody know what these options are? How can we make everybody talk to everybody? Let's remove the main VPC for a minute. Option one, let's fully mesh them like in a triangle. Then everybody will be able to talk to everybody. New York, London, Mysore. Here's how we would do it. We would connect London to New York, Mysore to New York. Oops, there's got to be a better way to do this. And then we would connect London to Mysore. Now can everybody talk to everybody? Well, let's just remove the main VPC for right now. Can London talk to New York and Mysore? And can New York talk to Mysore and London? And can Mysore talk to London and New York? Is everybody able to talk to each other right now? Yeah, so right now, if we fully mesh them, meaning fully mesh, everybody will talk to everybody. But see, building all these connections, the New York to London one, with 3 sites, it's no big deal. But there's a formula. It's n times n minus 1 divided by 2. That's the number of connections. So if we were going to fully mesh these things, and we've got 10 connections, or 10 sites, it's going to be 10 times 10 minus 1, which is 9. So 90 divided by 2 is 45. Crazy connections. So we've got 2 ways that we can fix this if we don't want to do full mesh. And I've seen one of the answers, and it's right, but there's 2 options. And it's important to know which ones to use. So let's figure this one out. So let's say I want to connect all these sites with VPNs. I'm going to create a VPN between the main VPC in New York, and I'm going to create a VPN between the main VPC in London. Just didn't mean to do that. Not the best box drawer in the world, but it gets the job done. And now let's say I want to connect Mysore to London. Right now they're still non-transitive, what we had before. But let's say I want them to be transitive and we're using VPN connections. What would I use in this hub and spoke environment to make VPN connections work so everybody could talk to everybody? What would that AWS service be called? With VPNs. Before I answer that, somebody's got a partially correct answer there, but it's more phrased as a question. So, what is the service that AWS provides to provide transitive routing in hub and spoke environments? Ian, great job. That's Cloud Hub. Nick, you were on the right track. Cloud Hub is used when there's VPNs. So for VPNs, we're going to use Cloud Hub. Everybody with me? Let me know. So, Mr. Todorov, when you want to use, so what happens is Cloud Hub is an AWS service that basically operates like a BGP route reflector and basically violates the rules of non-transitive routing and allows transitive routing. So VPN Cloud Hub is a device where you'll connect all your VPCs to here. You'll be connecting via eBGP, and therefore New York's routes will be given to London, and London's routes will be given to New York, and so everybody will have full routing information, so they'll be able to reach each other. Now, let's say we didn't want to use VPNs and we wanted to use a direct connection or a private line. Now what kind of service is it called? What's the service called when you don't use a VPN, you use a private line? Let me know in the chat box. You guys are doing great, by the way. Really fantastic. We've done 4 days of 3-hour network training sessions, and you guys are really doing great. Very excited and proud of everybody here. I just can't see you, and I can't talk to you like we do with our students over Zoom twice a week. So, just trying to make sure you guys are here. And keep you awake, because networking can either excite you or put you to sleep, and I've been in both. Been in networking a long time. So now if we want to use private lines instead of VPNs, what are we going to use? Well, when we're using these private lines, we still have the problem of non-transitive routing unless we use another service. So we use Cloud Hub for VPNs, and we use Transit Gateway when using private lines. Are the things that different? They're pretty much the same service with different names, but one's designed for more VPNs and one's designed for more, giving you more flexibility, because Transit Gateway could work with a VPN or a private connection. So it's a better, more usable version. Transit Gateway, everybody, exactly. Now, Arif had a question there, and I know Arif, and Arif is super, super smart. So when he's got questions, I want to make sure we answer them. Because if Arif's got this question, probably lots of other people have this question. So Arif, when you said when you use a VPN to connect VPN, I'm not really sure what you're looking for. Are you asking, Arif, when we use a VPN versus a direct connection? If the answer is yes, let me know that below. Or if you're answering when we use VPNs versus VPC peering, if that's the question, let me know and I'll answer that as well. I just want to make sure I answer the right question. Okay. Anybody have any more questions for me on this? Oh, VPN for VPC pairing. Great question, Ray. So when you have remote sites and you need guaranteed performance, you're going to use a private line. When your remote sites can tolerate additional latency and packet loss and lost data, then you can use a VPN. So I like to look at VPNs this way. If I need cheap, fast, and inexpensive, I'm going to use a VPN, meaning fast to set up. If I need guaranteed performance, or if I need reliability, I'm always going to use a direct connection. So VPNs are best effort, direct connections are guaranteed. So I hope I answered your question there. The reason people would use a VPN for these things is it's fast and cheap and easy to set up. Basically, look at it this way. VPNs are a convenience or a cost factor, but they're nowhere near as reliable as a direct connection, or the performance is not guaranteed. Okay, Uwiki, there's 2 ways you can deal with this, and this is an exceptionally good question. So let's map it out for you. You guys come up with good questions. Let's build them. Really great question Uwiki asked. So this is a pretty common problem. Problem 1. Let's just say company 1. Let's say company 2. Super common problem. Company 1, who's using the 10.0.0 /8 address space, because it's RFC 1918 private addresses, buys company 2, who's also using RFC 1918 private addresses, again the same 10/8. Now in this environment, if we connect these two, can these guys really talk to each other? Or will we have a problem because they're using overlapping addresses? We have a problem. They can't talk to each other. So what you typically would do in the real world is the first thing you would use is you would use NAT. And you would translate the addresses between 1 to 2 and 2 to 1 to some other addresses so you don't have overlapping IP address space. And then what you would do is you would start manually changing the addresses on company 2 because company 1 is the owner of the bottom. So over time, you would change, say, the 10.x addresses to, say, the 172.16.0.0/16. That'll give you 65,000 addresses, which is enough for most organizations. So you might swap it to that. Or pick another subnet. So that's typically speaking what you would do is you'd use NAT. And then until you're done using NAT, you your IP addresses. But what about on AWS? You can't do VPC peering with overlapping IP addresses. They don't allow it. But they have another service that automatically does NAT and allows VPC peering with private IP addresses. Does everybody remember what that's called? It's called Private Link. And what Private Link does is it effectively puts an elastic network interface on both sides on the same subnet. So we'll just put this E and I. Maybe that's not going to look super pretty. Let me make this a little bigger. Good. They're on the same subnet. Now we've got NAT moving, and Private Link automatically does NAT. Now you've got, Now you've got your two VPCs that are talking to each other, your wiki. So I hope I answered your question. This is how you deal with overlapping IP addresses on the AWS cloud. You use Private Link, which effectively brings you back to what we all used to use, which is using NAT. Derek, your question is fantastic. So let's map it out again. I wanted to show you exactly what this is going to look like. Because there are stops along the direct connection. So let me show you exactly what the hops look like, Derek. Great question. Okay, in this environment, Derek, what you're asking is as follows. Traditionally speaking, when you deal with a direct connection or a private line, what you're dealing with, and yes, I'm a private link is a service in AWS designed for that purpose. So traditionally with a direct connection, basically you buy a wire from New York to London, and it's just up and running. It's simple and elegant. It's wonderful. But it doesn't work that way here. What happens is you basically get a connection to this point of presence of this direct connection location center. And basically you're buying a link from your service provider between you and the direct connection location facility. So maybe between me and the point of presence. From there, what ultimately has to happen, in order to get on the AWS network, I need to get off of my network. So you can see I've got a WAN link which goes to the direct connection location for which it says customer router. From the customer router, I need to plug into the AWS switch/router. So I get what's called a letter of authorization, or that enables the service provider to plug a cable directly from my router to the customer router to the AWS router. And then where it says AWS backbone, where you have these little pink things, what's actually going on is these connections between the direct connection location center and the AWS account. That's going to be AWS. And typically speaking, it's a layer 2 backhaul, and that's why they ask you to send you the information. So Derek, as I said, yeah, the direct connection does not exactly go straight. So is there an appliance that gets in the data center? Yeah, it's a switch or a router, or a layer 3 switch, which is a router, so versus a layer 2 switch, which is a switch. So there's definitely going to be a switch or a router of yours sitting inside of the direct connection location, or hardware that's dedicated towards you. Ike easy. Is direct connection the same as a private link? No, not at all. A direct connection is a private line, which is a WAN link that you purchase. Private link is an AWS service that creates a virtual private connection between your VPC and another VPC, and it's used instead of VPC peering. Mr. Todorov, if you're using a direct connection partner, then what you're saying is correct. Using a direct connection partner, that they will make the connection between them and AWS. But if you're getting a true direct connection and you're not using it through a direct connection partner, you're buying the link to the direct location locator, and then there's this cross connect that's done. So Derek, it's not really an internet service provider you're going to be using. It's going to be a service provider. Internet service providers are giving you internet access. Service providers are giving you private link access, which is different, or private connection access. So, and private link uses private stuff, Lama Sharma. It's not a public internet. It's AWS backbone. So regarding Derek, so AWS is providing realistically nothing. AWS in the direct connection location will have their own switches which connect to their network, but your switches or your devices are going to connect back to you. So the customer router is going to be your stuff, which is going to be both in your data center and the direct connection location. Even if it's managed by your by your service provider, which could also be internet service provider, but internet service is related to stuff to the internet, where your private lines or direct connections or private internal networks to you, you're basically buying a wire. They're a little different. Did we answer those connections for you? Okay, so we've been here 3 hours a day for the last 4 days covering network stuff. We did some architecture work. We answered lots of questions. Did you guys all have fun? Hope you guys all had fun. Well, now you can get 100 gig Ethernet ports as well, thankfully, because the 10 gigs were not nowhere close to powerful enough for a lot of people. If you guys are not our students and you're interested in training with us, I've listed a link for our training program. I'm also listing a coupon code for 20% off. If people have questions about our training, they can call our office. I strongly recommend everyone here that's not one of our students to attend the 2 following free trainings. First one will be a How to Get Your First Cloud Architect Job webinar on Monday. Alonzo, I'm glad you'll be talking BGP in your sleep, because that's basically what built my career. I gotta say, BGP built me an incredibly great career. And I know Chris posted it, but I strongly recommend that everybody take our free architecture training on Tuesday. My students do it all the time. But if you are not one of my students, come to the free Cloud Architect Experience webinar on Tuesday. You will ask me questions, and this will be on Zoom, so you'll be able to talk and ask. We'll be having a party. You guys will ask me questions. You guys will design a cloud architecture from scratch. And the people that tell me, my students that come, they absolutely love it. Of course, it'll be a simplified version of what my students and I do on every Monday and Friday. But sign up for that experience webinar. I think you'll have a wonderful experience for all. So I hope you all had fun. It looks like a lot of you did. If you can let me know by typing Cloud Architect, please let us know. If you guys want us to do another kind of free training, let us know. I know some people want to do some subnet training. We'll try and do that. If you guys want me to work through some architecture stuff, kind of let me know. And most importantly, if you're having fun, please like this. Please share this video with others. And if you're not a member, like and subscribe to our channel and share this video with others that you can help. We want to produce free certification materials and share the world. We have a completely free AWS Certified Solution Architect Associate course. The link is in the description below. We have a completely free AWS Certified Solution Architect Professional course. The link is in the description below. We have completely free AWS Certified Solution Architect Associate ebooks. Again, get them. The links are in the description below. And tell us, Cloud Architect, if you're having fun. We'll make many more videos like this. People want more networking content from YouTube? Say cloud network training, let me know. If you guys want my cloud architect interview training, let me know in the comment section. Cloud architect interview training. Thank you for attending, Michael, and you're welcome. If you're interested in cloud architect career videos, let me know. Just let me know what you want in the comment section below. This is how I know how to do it. Chris from my team is aggregating questions and requests, so he will be the person that says to me, Mike, everybody wants this. So I'll know to make it. So please help us, help you guys learn everything you want by telling us what you desire. Okay, awesome. All right, I got a pretty good feel for what you guys like. The more stuff you guys want, no. You know what I'm going to do? I am going to film this weekend a cloud network interview question video where I will cover 10 common cloud networking interview questions. And Yogesh will make more cloud networking things. And Priscilla, much fun. I love hearing this because there's a lot of effort to put these on and we want to really elevate the community. Derek, Subnetting Insider. Yes, it's coming. Got it. Gotcha. Thank you. Thank you guys for letting me know. You're welcome. Arif, it was wonderful having you here. Alonzo, that's the nicest message I've heard in a long time. Thank you so much. We'll give you some bonus stuff. You got it. More AWS, we'll do some more one. We'll do some more AWS. Containers, we could do something like that. Thank you, Hand of God. I truly appreciate that. I'm trying to do everything I can to help the community. Okay, well, it looks like the questions are dying down. It's been a true honor to spend the week with all of you wonderful folks. Hope you guys have learned a lot. Hope we've been able to help you as much as we possibly can. And I look forward to seeing you in the future. Please like this video if you can. Please forward to others. We're going to get you more on cloud security, cloud networking. I see lots of people are looking for that. More on subnetting, you got it, Ned. You guys tell us what you want. We know how to produce it. So please, 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 tell us, tell us, tell us. Thank you so much. Peace and blessings to you as well. You're starting your career in cloud computing? Yes, I've got a lot of advice for you. The best thing that I can tell you is to attend my Monday and Tuesday webinar next week. On that webinar, I'm Emergul. We will first teach you everything that you need to know in order to get hired, every skill that's critical to the cloud architect, what your resume should look like, what hiring managers care about, how to earn a higher salary, and how to do all of that. I'm Ragul. That'll be on Monday next week, and we'd love to have you there. And on Tuesday, what we're going to do is we're going to show you how to design an architecture based upon customer requirements. So please attend both of those free meetings. I sent you the link to the first free one, and I'll send you the link to the other free webinar right now. Attend both of those, and I think by the end of next week, you're going to know a lot more. Stateless and stateful firewalls, Yogesh, that's a really good one. We'll talk about access lists, which are stateless, versus stateful firewalls. You got it. Chris, we can take that one down. That's a great one. Priscilla, you're welcome. Ned, you got it. Alonzo, you have a really wonderful day. And Derek, always appreciate it. Thank you so much. Take care, everyone. Have a wonderful, wonderful, wonderful weekend. For my students, I'll see you guys on Monday. For people that want to be our students, give us a call or register for our classes or attend one of our free webinars. Free or paid, we want to make sure we do everything we can to help you in your careers. There's the number to our office. Thank you so much, everyone. Such an honor, such a privilege to be here with you today. Thank you so much. And if you see me looking to the left or the right while I'm doing these presentations, what's going on is I'm using multiple monitors and I'm trying to figure out on one thing what you're seeing versus what I'm actually at it a second time, because there's a 30-second to 1 minute delay at all times with this YouTube, the way we're doing it this way. So thank you all. It's been a real honor and privilege to be with you, and I look forward to seeing you very soon. Take care, everyone.